I don't know. They need last year. Sure. I don't know.
I just spent the last hour getting through my 24 hours of emails.
All right.
Here inside.
Yeah. Okay. We'll start again.
Yeah.
Do
I just look at the camera?
yeah,
Because
the camera's good. Yeah.
Because you're moving, so...
Yeah, I'm just trying to get nice angles with it. Please introduce yourself.
Hi, I'm Shreyas Tarashri. I'm the Vice President of Compute at Imagination. I look after Imagination's compute products, which include CPUs, our AI technology, and our graphics compute, GPU compute products, and the associated software with it.
What is the RAI technology you mentioned?
Yes, so we can run accelerators, neural network workloads on GPUs as well.
And here at your booth, you're showing lots of hardware around.
We announced in late 2021 that we are developing RISC-V CPUs. We launched our first product, and in front of you, you have on an FPGA. It's an RTXM 2200. It's a real-time embedded CPU.
So it's running in this FPGA right there?
It's running in this FPGA here. It's IDE, which is a Visual Studio Code-based IDE, which is unique. And it's running a simple application here. So we have a customer who has already licensed it, the first CPU. So as and when they bring the chip out, that's when we'll get our first silicon back. The real-time CPU, it's an 11-stage pipeline. It's a high-performance embedded CPU for real-time applications. Nanometer process node. So that's the kind of applications we are targeting are embedded sort of helper cores, management, SoC management cores, power management cores, but this implementation in a larger SoC and anything which is to do with real-time deterministic behavior.
So Imagination is famous for the GPU technology?
Around the booth. A lot of automotive partner demos. We have one with Telechips.
Towards it. Yeah.
One with Telechips here, which is actually display. Here you have a kind of, because it's hardware virtualized, we can run multiple OSs. Here you're seeing a Linux running alongside an Android.
Is it an ARM core?
The CPU in here would be ARM CPU.
But chips design, and then they use PowerVR.
We are also partnering with other RISC-V companies with our GPU. So here we have a board, which is a Star5 CPU running within Imagination GPU. So we are enabling the ecosystem. We're working with everyone in the ecosystem to make the RISC-V more successful. Here again, another a T-head, Alibaba's T-head RISC-V CPU with Imagination GPU, and it's running Android at the moment. So range, we are actually the only GPU provider for RISC-V, and we are saying it's the GPU of choice for the RISC-V architecture.
All right, because you have the experience making the Android stuff to make it work on the RISC-V.
No, so by default, our GPUs are OS or CPU agnostic. So it wasn't a very heavy to port it to RISC-V. But of course, with our own internal RISC-V development, we have all the in-house experience of developing these use cases.
So this is
in a GPU company for almost 3 decades now. So you have real products out in the market
for all the ARM-based.
Yeah, for some time. This is single board computer that's available now. It's moving at a very, very fast pace. RISC-V has disrupted the status quo. And we are seeing more and more, practically everybody here in existing CPU providers to RISC-V.
For example, when you have a UI like this, which looks a little bit like automotive
yeah.
margins to this platform compared to previous platforms.
It's not hard because GPU for graphics use cases are things like OpenGL, OpenGL-ES. So we support those Chronos standards. So the APIs are all standard and it's easy to port.
Nice. What do you show here?
Compute use case where we have a chip, a Renaissance R-Car platform with Imagination GPU. Running alongside with our near is a surround view use case where the GPU is actually doing multiple functions. It's actually rendering the car here. It's stitching the and neural network accelerator here is actually doing human detection or as well on the scene. So it's all, and these ones showcasing you. Again, you can see reflections being reflected on from the camera onto the device. Just to exaggerate, we can. I think the gold color shows it very nicely. So it's actually showing reflections. We can go right in the car, and actually we are now showcasing the same sort of surround view in a cockpit environment.
And all this will be running on one
SOS, but we have hooked it up with our neural network accelerator to give that a full surround view use case.
the RZ.
R.
The H3 platform. All right. Anything else here at the booth you were talking about a lot? Oh, there's lots of discussions about the future.
Yes, lots of discussions.
Cool. All right. Thanks a lot.
Thank you.
I will ask her for the contacts and then I'll send a video after. It was live? It was live streaming? Yeah. Tonight, tomorrow I'll publish in 4K. Thanks. Cool. I'll send you the video there. And so it was live streaming. I'll give you my card again. Yeah, you have that?
I think yeah.
If you want like something very cool, or otherwise maybe I'll find on your website something about the latest. Whenever you have the latest press release or something. Okay. Thanks a lot. Okay, see you.
Se acaba de unir.
All right. Maybe you can film me for a second. All right. Let's see here. Kornhofer.
What do you do? Oh,
Is it possible to bring it on the table out there?
Because
I'll give you my card.
is it?
hard to
Oh
film
yeah,
inside the glass.
but you sent me an email. I didn't.
Please introduce yourself.
I'm Steven de Land. I'm the operational manager of IMEC IC Link. So of chip services, anything from design to supply chain of ASICs, application-specific ICs.
So what's the latest technology you're showing here?
We are able to provide customers with 3 nanometer technology, which is the latest technology from TSMC. We're a broker for TSMC, a value chain alliance partner.
How do you make it work so small?
IMEC is a research organization based in Leuven, Belgium, and some other parts of Belgium and the world, where we do research on new transistor concepts, new materials, new ways to make it work. So we're actually helping the foundries to make it work. I personally don't know to abstract the smallness of everything to do that, obviously.
What are you showing here?
This is we're on our booth now at Embedded World, and well, it's hard to show things at a mask set of a TSMC chip, several chips. You can see several chips on the mask. There's in this technology, I think there's 36 masks that are used to create chips on.
So there's a mask before the wafer?
So there's several masks that are used in a process where it's layer upon layer upon layer upon layer, the transistors and the interconnect between all those transistors.
And somehow the mask is square and the wafer is round? How do they, in which part of the...
On the mask is repeated on the wafer. You can see that pattern here as well. So light is shown through the mask on the wafer, where there's photoresist on the wafer, and it's the mask.
But why do you have 6 by 5
Well, this
here?
is what you see here is the reticle of the wafer, and for this chip, we were a wafer. It's optimizing the area, the silicon area, and the cost hence.
A very good mask on the 3 nanometer tech. Millions and millions and millions.
It's a set
euros,
of masks. In the 3 nanometer, it's in the order of 50, 60 masks, something like that. And well, yeah, it costs.
That's a lot of money.
Many millions.
And somehow this mask has 0
Thing is a very important part of chip making. So yeah, there should not be any defects on the mask, because otherwise every defect will translate into a wrong chip.
How do your colleagues and yourself have the capacity to design something so complicated that just
As I said,
works?
we're abstracting. It's by using abstraction. It's by not looking at transistors anymore, but at logic gates, and not looking at logic gates anymore, but at building blocks. That's the only way we as humans can grasp the millions and millions and millions of transistors that there are on one chip.
Is it a game of software and the software just takes care of it, or do you have to...
we wish. There's a lot of software, and the software takes care of a single transistor in a multi-billion transistor chip, of course. There's a lot of software help, there's a lot of pre-built made blocks, but the human in that process is very important. We have area, and that's a human thing. I mean, there are tools that are integrating AI as well in this process. They're pretty, but still the human is still the factor, right?
I won't be able to zoom in on 3 nanometer. I don't know if
This is not 3 nanometer.
But the way they're designed, heat dissipation around the chip, like put things in the right place so they don't.
There's many things to take care of. There's like the power mesh on the chip, for example, all the right timing. And if that's not the case, your chip will not work. Or it will not work intermittently, which is even worse.
And when you do the right design, the yield
is mostly related to the process itself and the layout of the chip. They work together. So you have to make a layout that is as well. At the end, just before you're taping out, as we call it, go to production, then we do a check, which is a design rule check, which
how would you define your role at IMEC? Are you very much working together with the EDA industry, or you different? What is your?
Well, we obviously we are using the creation of new knowledge in that field. We are users of EDA, and we work with the whole ecosystem of failure analysis companies, etc.
So what kind of discussions you have here in the embedded world? What people come to ask you about?
Oh, it's nice to see a lot of people. Future possible projects, new people or new customers that are coming with ideas to create new chips. Partners.
A lot of themes like the edge and IoT and low power microcontrollers and everything, and you have a role to play in all these different things.
For us, it doesn't really matter which application it is, but obviously we see some applications being more sought after than others. Yeah, there are these things that are...
Because there's so many, when you have 3 nanometers, there's so much space on your chip, and they just put they put the AI and stuff on the big part of the chip now, like to take advantage.
I don't think it's more like that. With chip, the silicon real estate is defining your cost. How big the chip is greatly defines your cost. So putting something on there just because I haven't seen it happen really.
All right, cool. Okay, but thanks a lot.
Okay.
Thanks. Did you want to jump in? No. Video? No? Cool. Playing cards, I think. Did you? Was you doing that?
No. He was not with IMEC.
You were not?
If you made a video of Global, then maybe. No, he just joined us 1 week and a half ago.
Designer. Oh, okay. Cool. All right. Cool.
Yeah, that's also one thing that I don't know. You as a blogger, there are many different.
Hello, my name is Manuel. I'm the product manager of our UI tool Embedded Wizard here at Taro Systems, and I'm very delighted to present you a couple of new products in terms of graphical user interfaces.
So what are you showing here?
In fact, we have different products out there our customers are using, from consumer electronic appliances and industrial as well as medical.
All right. So for example, this one has i.MX RT, and then you make the PCB that makes it all work?
In fact, no. The hardware itself is done by our customers itself. We are providing the software, the GUI solution, in order to get some nice looking user interfaces and HMIs running on such embedded systems.
All right.
i9, which is one of the brand new microcontrollers from ST Microelectronics, and something which is very nice to view at. 160 megahertz microcontroller, and just have a look what fancy effects you can do on the new Neochrome GPU available on the new U599.
What is this?
The Neochrome GPU is the successor of the previously added DMHD, the Chrome Art, which is a graphic accelerator built into the chip that can offload the CPU while running on. And remember, could be an M7, but I'm a software guy, so I'm not a hardware guy. It's a microcontroller.
Part
Absolutely.
on the microcontroller.
Yes, correct.
And then it makes all kinds of fancy.
And while offloading the entire CPU. So CPU can do other things and are free, where are still there in order to get a nice and responsive user experience for the customer.
Nice. What other stuff are you showing here?
We're presenting our independent software vendor, which provides software to different kind of customers and domains. And with our software stack, Embedded Wizard, we provide a very lean, versatile, scalable and fast solution for the entire embedded world.
I see a lot of other ST solutions around here. Are there different kind of chips used?
Yeah, sure. We have, as said before, the very famous H7, which is also a microcontroller, but on the left we have the MP135, which is the new MPU coming from ST Microelectronics.
Let's go check it out. So it's the next gen.
And we can achieve a very high frame rate by utilizing the ARM Neon instruction set, which gives us a boost in terms of graphical rendering performance.
What is the OS?
There we are running Linux, so it's a classical Yocto Linux. Of course, on the microcontroller itself, we are running on FreeRTOS or bare metal, depending on customer needs.
How good is Yocto? How smooth does it run on these STM32?
Marvelous. Honestly speaking, so we just use what is there, so it's not something our part. It's available and.
And you also do a lot of different things here.
Yeah, so it's, as said before, we're an independent software vendor, hence not only relying on ST, but also on other semiconductor manufacturers like NXP, Renesas, Ambic, Espressif. So, in fact, everywhere where you can find a display is something where you can find an embedded wizard.
What's one of the other coolest new platforms you have here?
Hold on, let me double check. Perhaps something. Out of the Mix 8, but this is more or less cash cow for NXP because that's the stack that's available since many months. This is the RZ G2L and the RZ G2L, and this one is there the highlight that we are using blurring and shading for presenting nice graphs on the display.
Nice. How long have you been wizards in embedded?
It's been a while, and it's not the first generation that we are providing. In fact, it's already the fourth generation of UI is providing to the market.
Fourth generation of what?
Yes, of UI software stack for the market.
So on the TV.
On the screen, we see our portfolio that we can do. Of course, we have the software stack, but UI development, and there we are showing customer cases in different domains, as well as the tooling itself, in order to accelerate customers to get their UI up and running on the target.
All the time to update it all the time. They can update themselves later.
Otherwise we would get mad. No, we have a very sophisticated stack out there, great documentation. Of course support is there, but the main aspect is empower control, because there are no third parties and no open source stacks used.
Cool. All right. Thanks a lot.
Thank you. How is the process?
Hi, please introduce yourself.
Hi, my name is Johnny Slumpf, and I am a senior systems engineer for Altia. Altia is an embedded toolchain expert. We're in over 100 million devices in the world. We run on all sorts of different systems from the low end to the very high end, taking your graphics, whether that's 2D or 3D, on the hardware of your choice and the display of your choice.
Nice. What are some of the latest platforms you show here?
So we have quite a few platforms. Over here, this is running on the Renesas R-Car E3.
So this is the, they call it the R-Car E3. Is it powerful? ARM Cortex A53?
That's
R7?
right. That's right, yep, and running free.
The charger.
Yeah, up here we have a model of a car charger. It's running a real car charger inside. This is running on the latest TI Satara chip.
Deployed, or they're just prototypes for now?
These are prototypes, but running the full board inside.
What is the advantage on having a touchscreen like that? What is it going to be able to do?
Yeah, so you'll come in and have change your charging. This is, of course, we're just showing off the UI that's presented to us in the most optimized fashion, running on the hardware.
Nice.
Yeah.
And what do we?
This is our integrated cockpit for electric vehicles. It's running on a Qualcomm 8155P. This is actually run on a multi-visor. This is running an Android subsystem. 3 windows here. This one's running 3D here, 3D. Bring up different windows as well and rearrange them.
That's a lot of graphics on one SoC.
On one SoC, yeah, the Qualcomm. And this is quite similar to the kind we're running Altia.
And this is a pretty big car to have such a big display. But some of them have these giant displays.
They do, yep. The Cadillac Lyriq, earlier days from the very small displays and just kept growing and growing from between the cluster, the entire cluster becoming digital, adding in the multimedia section.
The advantage here with we call it the SA815SP.
Yeah.
So it's powerful, one of the latest ARM designs, and
That's
then
right.
it maybe has baseband, include 5G and everything potentially. So when there's a next gen, you can port all your solutions to next gen and just keep improving.
Absolutely. One of the advantages of Altia is that we are operating system and processor and BSP agnostic.
Behind you is a little bit busy right there.
Yeah.
We try to see if we can sneak in and film this kind of stuff over
Sure.
there. It's been busy here at the Embedded World.
Yeah, very. This is, I don't know, we've been in Embedded World for maybe, I don't know, quite a few years now at least. It's been very busy. It's a great booth. We're fortunate enough to be near the entrance of Hall 4 here and having just a lot of...
right there I see NXP.
Yes, so on the end here we have the NXP IMX 8M Plus.
So what's happening with this NXP here?
Yeah, so all 3 of these, E and 3D in real time. And then behind that you'll find the STM32H7 and the STM32MP1, also running the same design. This is the STM32. This is the MP1, and it is actually running the human body rotation. Also the option from Altia is you can just flip that over to run 2D, so simulated 3D on a lower end processor. On the for that processor,
2D stack, but it looks...
yeah, but it appears to be 3D. Yeah, I mean, it appears to be 3D, right? Yeah. Cloudware. Altia Cloudware. In the modern days of distributed teams, it's often hard to get the hardware to those engineers and to ensure that the hardware up in a kind of a server farm in the cloud. We have, I think, 7 different systems right now, and what that means is that you can design editor, that's our GUI creation tool, drag in your graphics 2D or 3D, and instead of deploying that to hardware that's sitting on your desk, you deploy it till the Altia deploys it to the hardware up in the cloud. in your browser, it will bring up a video display, which is video capture of the screen. But in addition to that, it has a lot of versatility and very easily can switch between different platforms and get up and running literally on hardware in minutes instead of weeks, months, or even years in some cases.
Nice. So how you work?
Exactly right. Yeah, Altea has been in this industry for almost 30 years now. This is one of our latest innovations, Altea Cloudware. Off the fly, let's do it.
Nice.
Thank you.
That's awesome. If you want to get Hi.
Hi.
Please introduce yourself.
Hello, my name is Julie and from Astra Industrial, and we are the world leader for the motherboard and for the system. So you can see here we have different kinds of form factor like ATX, mini ITX, and also has 3.5-inch form factors.
What is a 3.5 inch? It's very compact.
Yeah, it's very compact, and we have the different kind of SKU, and we follow by Intel every generations to make our motherboard.
What do you see? What do you mean by world leader? You ship the most
Yes,
quantity?
we ship the most, and we have the customer around the world.
All right. What is the latest designs here? The most
Latest
interesting you're
design-
showing.
Yeah, latest designs, we have the latest generation is the Raptor Lake. Yes, which support DDR5 with PCIe Gen 5.
And what's the target here at the embedded world?
Uh,
Many people use this kind of boards in the embedded world.
Yeah, and lots of people using the industrial, using the IPC industrial. Yeah.
So should we go this way or that way to
We
show
can go
more?
this way.
There.
And here is our latest product, which is the system level, and we make it with compact size and with wide temperature, wide voltage.
So here and there goes an Intel 13th generation with all the RAM and everything.
Yes, and we have a bridge I/O, and also have the expansion slot here, so customer can put different kind of the graphic card inside in different slot.
You can add the graphics cards right in there. And
Yeah.
where is this going to go? What is the application for this?
Mostly using the automation.
Automation, like in the factory,
Yeah,
maybe.
or
All right, and
AI AOI application.
And here you have smaller.
Yeah, we also
Let's
have
see.
the compact size for the smaller one, and also have the entry level for the controller.
With COM ports and everything.
Yeah, and this one is the entry level for
And it says
alcoholic.
Ubuntu certified.
Yeah.
All of it?
Yep, yep,
All right, so you work with the
Yes.
Linux, the
Yeah.
Windows, the everything.
yep.
All right. And there's even these little boxes here.
Yes, we also
Ah.
have the mini PC here. So mostly used in, we have the fanless designs and also have the fan designs for Intel and AMD solution.
Do you work on the ARM chips? Do you work with any of these Qualcomm,
we
NXP,
We mostly use for x86.
all of it?
Yeah.
Okay. AMD also?
Yes, we also some of the motherboards AMD, but do not.
Not here.
Yeah.
All right. Cool. Thanks a lot.
Thank you.
introduce yourself.
So I'm Olivier Kreit. I'm the multimedia lead here at Collabora, and I can show you this is one product that we've contributed to. It's a MediaTek-based Chromebook, and we've done quite a bit of work around bringing upstream Linux support for various IP blocks that are found in ARM.
Is it one of the latest Compagno or one of these chipsets?
I think so, yeah.
One of these latest MediaTek?
Yes, one of these.
And is it just a regular Chromebook? And
This
you
is
can
a
run,
regular
what
Chromebook.
kind of, what is Linux? You can do the Linux?
It's Chrome OS, right?
Just Chrome OS.
This is Chrome OS. This is off the shelf. We just went to a store and bought it. But we've been working on it, because the ones we work on, obviously, we cannot bring.
Can you explain what is it, part of it that you work on?
So we've done work on, for example, the codec hardware, but also other bits of hardware that we've upstreamed to the Linux kernel. And also we work on, with Google, on having these devices in the kernel CI project, which is a project to do continuous integration on the Linux kernel itself. So upstream, running, whenever someone submits a patch to the upstream Linux kernel, we build it, we run it on hundreds of devices, and we report to the maintainers what works and what doesn't, especially what doesn't.
All this work is useful for when people want to run Linux on these too, right?
Yes, yeah.
Not just the Chrome OS.
Not just Chrome OS, right? Because a lot of what we do is we bring the drivers to upstream Linux, so you don't need a special kernel. You can just use the standard Linux kernel, which is useful for someone like Google, because they have 8-year support on these things, right? So they want to upgrade the kernel. They just don't want to ship an 8-year-old kernel.
What's happening behind you there on the screen?
So, this is our Lava Lab. So what we're showing that we're building different.
All these boards.
Yeah. So we have continuous integration across all these boards. So the developer writes some code, and then our system will build it for all of these boards, create a system image, boot the board with the image, and bring all of the results of all the tests that it runs into a UI where the developer can see. So it's easy if you have like a complex system that you might run on many generations of boards, many different types of hardware. Also, a developer who probably doesn't have like 10 boards on his desk to actually have more confidence in what you build.
The Lava has been developed for a few years, right?
Yes.
And it's open and everybody can implement it the way they want. And you have a special way to get it to the next level, or?
So we actually contribute to the open source projects directly. So it's not like we have our own special flavor. We're actually part of the community. But one of the services we have is that we host a Lava Lab where we can take people's devices, put them there, and then have part of both kernel CI and Mesa CI.
Yeah. All right. What else can we film here at the booth?
So the next demo, my coworker here, Marcus, will show it.
I can show it, yes.
Yes, it's an AI demo.
What's the latest happening with the Panfrost?
So
what are you doing here?
What we show here is basically a machine learning demo that runs on a complete open source stack, like operation system. But the important part here is that we use like an open source graphics driver. And what this demo is about is basically a video compression focused on web video conferencing. So basically, at the beginning of the call, we take like one image of the sender and send it over to the receiving side. And then following up, we just extract key points for every image, and we use these key points with the first image that we extracted to reconstruct the face. And that way, we are actually able to reduce the bandwidth 10 times in comparison to H.264, which makes sense because like we just transfer like the key points for every image instead of like the whole like video stream.
Is this working or it's just a prototype?
This is basically, I mean, more like a prototype than like a full-featured product, but it would be easy to just take it and integrate it into like an existing video conferencing software.
Because last 3 years, I don't know what happened. There was something weird where people had to stay at home and everything, and they were doing video chats.
Exactly.
So there's been a lot of talk of, there's been trillions of petabytes of of video conferencing bandwidth out there. And
Yeah, as I said, like
you
this
can save
complete
90% of it.
this complete demo is already like open source. You can just download it, flash it to your like embedded board or like your PC and just use it. And like the next step would be to actually integrate it into like an existing video conferencing software like Zoom or like Microsoft Teams.
You could potentially have Rockchip powered 4K
Yes.
webcam, and if the other guy also has it, or even if they don't, or I don't know, the software has it,
Even if they
then
don't
suddenly
have it,
they can see you 4K image with 10 times less bitrate.
Yes, up to 10 times lower bandwidth.
So you could do 4K video conferencing with like 1 megabit.
Yes, you could. You probably need like a little bit more capable hardware because like this one is like very resource constrained. But it would be possible to run like in 4K. Yes.
I did a video with NVIDIA once. They talked about some all kinds of optimizations there they were thinking of doing. I forgot what it's called, but I guess you like to do everything in the open source, so everybody can use it.
Yes, the
question
benefit
is, how soon are people going to use this in products or?
We hope pretty soon. As I said, like the next step would be to actually integrate it. But since this is open source, we can actually optimize every single bit. As I said, it runs like on an open source graphics driver, which actually allows us to optimize the whole machine learning pipeline to run in real time, and also like support like 4K, for example.
Nice.
Which is like often not possible even on like NVIDIA hardware, like the NVIDIA Jetson.
How good is the Panfrost? Is it
It's
fully
at a
working? Everything
stage
is
where
perfect?
It's like
Or is this
really good and works like out of the box.
really good out of the box?
Yes.
All the Mali
Yes.
GPUs?
Not
No matter
all
what.
the Mali GPUs. There are like a couple. There are like more supported than others, but
The newest ones, they get great Panfrost, or is the oldest one that have problems? Or
it's more like the more older like chips are like a little bit more supported. And are more optimized, I would say. Like it's always like a combination of software and hardware, right?
Because the latest one, I think they call them Immortalis, the GPU, and it'll take a while before Panfrost is ready for that.
Yes, it will take a while before like Panfrost is ready for this. Yes.
So ARM hasn't open sourced the GPU driver yet.
No.
They don't want?
I don't know if I can share too much about this.
Okay.
There are definitely like discussions in this direction.
Cool. Awesome. What's happening behind you? What else we can talk about here?
Maybe we can switch to them because. Do you want to give like an?
Really want to say that we take our advice to heart because of the trend.
All right.
Something that we
Let's see
can
if we
push,
can jump in there.
perhaps ROO at first and see.
You can ask them to,
we
if you
can
can
get towards that
just try to go
direction,
through.
but contracts you guys would be
Sorry, one second.
definitely
Can we just do a
possible.
quick video there? All right. Hi. Please
Hello.
introduce yourself.
My name is Laurent Pinchat. I'm the CEO of FIDEs on Board. We are a Linux consulting company specialized in multimedia and camera support.
So what does Ideas do on board? On which board?
Lots of boards actually. So our goal is to enable camera support for all of our customers. We make your cameras work for you. So anyone who needs to capture images to create a product, we enable that. We don't care about the end user applications, so we support customers in the automotive market, industrial markets, medical markets. Anywhere where you need to support cameras, we can be there. So we work with SoC vendors. We are supporting both from an SoC from Rockchip, from NXP, from ST, TI, Xilinx, all across the board. And we also work with OEMs who integrate those products and those SoC in their own products to enable them to use them as efficiently as possible.
When there's an SoC and it has support for cameras and stuff, isn't it just there, or what else do you need to do to make it great?
Unfortunately, many things, because usually vendors will provide a BSP with a custom solution. They will have a camera stack that is vendor specific. So for OEMs, switching from a vendor to another one is very difficult. Or integrating just support for another camera sensor on the same SoC is very difficult. You need to go through a whole tuning process that involves closed source tools, that involves usually working with the selected key partners from the vendors. That can be a long and costly process. So we want to create, and we are creating, a completely open ecosystem with an open source camera stack that solves those problems. We focus on interoperability between different SoCs and different camera sensors, so we can make any camera sensor work on any platform. And we also work on creating tuning tools to enable our customers to do the tuning themselves at a cheaper cost and leveraging all the knowledge they have in-house.
Just behind, I saw Libre Computer. Are you working with these guys? Is that your partners and all that? Or?
So we are partners of Collabora. They're hosting us on their booth. And Libre Computer is indeed a company that Collabora is working with. We have a working camera solution on some of the Libre Computer boards. And we partner with lots of SBC vendors. And
it's nice when I see the AI just makes the video codecs amazing. Are you also part of doing that?
Yeah, that's a Collabora project. That's a really cool one. That's actually a demo that you can see here.
Yeah, we saw it right there. With the
yes, it's detecting the face. That's the same one. So you do have face detection, and it's reconstructing the face and sending just the face over the network, lowering the bandwidth. So they have created this AI demo, and we have worked with them to replace the USB webcam that they were using with a RAW sensor. So now you can use the same demo on any kind of SoC with any kind of RAW sensor.
When there's can you describe one of the really cool SoCs that are great, but then the camera, the imaging chip is kind of like separate all the time, right? And they have to talk with the SoC, and there's what's the language?
There are SoCs that lack camera support inside, so you have to use an external ISP. That's usually a chip that will be between your RAW camera sensor and your SoC. That makes it more costly to integrate a full solution, but we do support some of them. We have worked, for instance, with Onsemi, with some of the external SoCs and developing drivers for that. So those are solutions that we support as well. So depending on the type of SoC you use, whether it integrates an ISP or uses an external ISP, that is something that we can work with.
Many of the cool ones have it integrated directly.
I wouldn't say necessarily the cool ones. I mean, there are lots of interesting SoCs that don't necessarily focus on camera support. They may have lots of other interesting features, but without an integrated ISP. But otherwise, yes, we're more interested in the ones that do integrate an ISP, because that gives usually a more integrated user experience.
Nice. Is this also stuff here?
Yeah, so those are samples of boards and systems that we support, just a small subset.
What are you looking at here?
So we do have the Debix board is based on an NXP AMX8M Plus. That's the first SoC actually in the NXP product line that integrates an ISP. It was a bit of a game changer for them. But we have camera modules from Audicam, OKdo, Raspberry Pi. This is a cool device actually. So this is a Raspberry Pi Zero behind the hood with a camera sensor from Raspberry Pi as well, the latest camera module. And it's actually used as a USB webcam. So it runs Linux inside, full open source support.
In there?
And yes, in there. That's the same one you have here.
There.
So that's the Raspberry Pi Zero inside. You run Linux on that, you run Lip Camera on that, and you connect it through USB to your computer, and it's recognized as a webcam.
Nice. Do you have what's the best platform if I want to do a 4K video conferencing? What should I use?
So if you go for higher resolutions and higher performance, we are looking at the moment at new SoCs such as the Rock 5 board, for instance, distributed by OKdo. That's based on the new Rock chip SoC. That's very interesting from a kind of point of view. We're just starting development on that, so that's something we fully support yet. But for the existing supported platform, the AMX8M Plus is actually an interesting one. It's very versatile. I wouldn't say that's necessarily the best one for video conferencing as such, but for lots of industrial use cases, including higher resolutions, we can support lots of applications on that.
What's cool about the embedded world, when you support a platform very well, it's going to stay for decades. It's going to stay for years and years. It's going to be useful for maybe potentially millions of products.
Yes, it does. And that's also something where I think we have an added value. If you look over here, this is a tablet running or developed by Google. That's a Chrome OS product. And they offer 7 years support and software updates on all the Chrome OS devices. This one is reaching end of life very soon, and because we have an open source camera stack on that, it means that user can even extend their lifetime beyond that. So you can use mainline Linux kernel, you can use Lit Camera, you can use open source software, and you have support even beyond what the vendor would provide. 7 years is already quite long in that kind of market. So that's good support from Chrome OS, but you can even go longer than that because of the open source ecosystem.
Nice. That means these Chromebooks get a bunch of updates somehow.
Yes. For 7 years from Google, and after that, depending on what the users want.
Cool. That's awesome. Okay. So that's a cool booth here. Lots of action happening. Where are you based?
I'm based in Finland personally, originally from Belgium, but based in Helsinki.
But here, the Collabora is a lot of French guys, or?
French. They have a big office in Montreal, so certainly French speaking, but not just. In Ideas on Board, we have 7 people. We're distributing over already 5 different countries. Collabora is much bigger, with around 140 developers, so they definitely span the whole globe.
And working in the open source, it's possible to make money.
Absolutely, yes. We're certainly not out of work. We have lots of requests from customers. We do not sell our software indeed, but we sell consulting services. We work with SoC vendors to enable their products in this whole ecosystem, and we also work with OEMs who want to integrate them later in the product. So any kind of support they need, that's where we come. And all the camera stack, all the kind of drivers, that's indeed released as open source, so everybody can benefit from that. But the other way around, we do benefit from the work of other developers, so that's also how we can be competitive.
Is it possible that somebody will make really cool devices? I don't know what kind of sensor size is here, but could you have like a 1-inch sensor, micro four thirds, APS-C, and just have amazing video conference or something like that?
Yes, absolutely. You could go for really, really large sensors. Obviously, if we're looking at the at extremes, there are sensors that have resolutions at 400 megapixels, for instance. You will need custom hardware to go with that, because it's such a niche use case that you will not find off-the-shelf SoC that will offer all the features that you need. But apart from that, you can go high resolution. You can go. I mean, this one is relatively large, but you can certainly go larger than that.
And you support it?
Yes, we can definitely support it.
You can work with anything people want.
Yes. The biggest problem we have actually when it comes to an interoperability point of view is connecting the sensor to the hardware. There's no standardization when it comes to those connections. All those ribbon cables that you see, they have different pinouts, different number of pins, and so that limits our customers when they want to connect a camera that's not meant to be connected to a board. So there's always some adaptation that you have to do. So having standardization in that field would be great. That's hindering development a little bit. But from a software point of view, we can really support anything. As long as we can establish a relationship with the vendors and get documentation to be able to develop drivers, we can certainly support them, yes.
All right, thanks a lot.
You're welcome, thank you.
Hi.
Hello, Nicholas. How are you?
So, what's the latest? The latest. What's happening?
Let's start again because I didn't hear that last bit. Do a video in a minute.
Am I?
Yeah.
I don't think so. It's a video. Maybe you can have Tyler. It's
No, Tyler's busy. We have to show the demo.
Well, how about what if Tyler?
No, Tyler's busy. No, Tyler's busy.
Not possible.
Tyler is busy.
Yeah.
He's got 2 major customers waiting for him.
Yeah. Okay. Cool.
I don't have other choice. Do I have another choice?
No, that's great. That's a good choice. Okay, let's try.
Hello, Charbucks. How are you doing today?
Hi. So, what's the latest you're talking about here? The embedded world.
Embedded World this year has really been about the growth of Linux and security. We have seen a huge change in the last 2 or 3 years from where security was just talked about to where it's starting to be implemented in real products. That's been driven by OEM's need to produce secure devices that can be updated for their customers. This is mainly in the industrial, robotics, automation and infrastructure space, but at some stage it will meet the consumer space as well. We're seeing huge demand of MCU customers moving from their current application layer into an MPU space where they'll need a heavier operating system like Linux. And so what Foundry delivers is the easy button for Yocto, easy button for security, which allows them to go and productize their devices 6 to 9 months quicker with much more security.
And you've been executing and happening. This thing has been happening the last couple of years.
We started the company 5 or 6 years ago. We were a spin out from Lenaro. We saw the need for a horizontal-based Linux in IoT. The same way as we had a standard platform in the PC industry, the same way as we had a standard platform in cloud. Even when Android came out, that standardized where the mobile phone was going. Now we have something equivalent in IoT that is not just usable on 1 or 2 devices, but a whole swathe of major SoC companies that work with us to have a standard Linux across an industry platform through ARM and x86.
And behind you, you're illustrating some of the stuff here that you're talking about?
Yes. So if you look at the illustration and we start over this side, most OEMs start here with selecting their hardware and they'll go into their EVK and BSP through their development cycle. They'll then go, okay, is that right? And they could come back again and they'll work through the BSP of the hardware vendor. That's quite simple to do. You can do tooling with that, you can do some proof of concepts with that. The problem comes down when you want to go into your own hardware and you have security in there and you have to build in the tooling and you have to build in the testing and you start going around this cycle. Security is one of the last things to be thought about and one of the hardest things to put in. What we do at Foundries is enable this whole cycle to be shortened because you're using the same code base from day one. You can choose multiple different chipset vendors. You have automatically built in the security. You have all of the Yocto layers that you can then customize to what you want. And as you go through the development and then into prototyping, it's the same hardware, same software layer. And then when you go into production, it's the same code base again. You've used automatically what you start off with, what you edit, what you develop, what you produce is the same code base. You don't have to go through multiple iterations, a proof of concept. And then when you go into maintenance, you have a full CI, CD, DevOps cloud giving you daily CVE updates with the full software stack from bootloader to Docker container on top that allows your device to be over-the-air updated with the most secure over-the-air update possible for IoT, all the way through the device life cycle for 10, 15, 20 years.
It seems like all-encompassing, like it covers everything, and you managed to do that. You managed to provide a platform that just rides everything.
We are probably the only platform that goes from bootloader through to Docker container through to OTA that allows OEMs to be very flexible with their SoC, to be very flexible with their cloud. We don't tell people where to put their data. We are cloud agnostic, we are SoC independent, but we add all the latest security from all the latest vendors.
So I've been going to the embedded world since 2011, and so all the embedded world has been having troubles in the security, and you're bringing that to the next level.
We're making Yocto and security easier. Security is never going to be easy. It has to be multi-layered, it has to be improved every day, every week. That's why we do maintenance and OTA, to make sure that all the latest CVs fully tested on your hardware every time you need it, so you can update your product in the field. This is almost unique in the industry.
And potentially IoT devices will be updated forever, potentially. When they sell a really cool product, thanks to your technology, it'll be just forever.
You can have updates as long as we keep the DevOps platform going. As long as you pay us, we will keep updating it because it's automatically generated for you.
Nice. All right, and here you have some demos at the booth?
Yeah, let me introduce my partner, Raul.
Hi.
Raul, do you want to do a couple of demos?
Sure.
Hi.
Well, this year at the Meta World, we are not bringing devices, but we are using Qemu because we have a large number of platforms we support. We decided to use Qemu, and that's enough for illustrate what we have.
So what do we see here?
This is some of the platforms we support. I will play the video so it will switch to another view where we have more platforms.
So we have, I see NXP, I see Arduino, NVIDIA.
We have a bunch of devices we already support out of the box, and the customer can always add their own device to the factory.
Let's go.
And like just pick one and it's fine. Like you can get started with us. Well,
work with the Toradex, all the different boards.
Yeah, we work with Toradex ST, TI, NXP, a bunch of NXP as well. And then like our demo this year is basically we have three stations at the booth. Each station has their own Qemu, and we can see the factory, which is a very good view on the CI/CD that we provided to the customer. Like we can see all the builds we have done for that factory. We have the platform and the container builds here in that view. And then we can also see the devices connected to that factory. You have this three station with three devices, all the devices following the same tag in the latest version. And also we can check which application is running on each device. Well, if we go back here to the device, one of the cool things we are demonstrating here is this is our device. It's running 5 different containers. And it's cool that we have a container running Flutter and another container running Qt. This is to show the beauty of container and the ability to isolate one from each other. So this is the Flutter application running in one container. And then I will switch to another application. This is our Cog browser showing our website. Switching again, I have Qt. So this is all running in the same device. It could be done on iMacs, on TI, or any device. And yeah.
So you're switching.
Yeah, I'm switching containers in the same device, just to show the ability of having multiple containers running the same device.
Is that something many people want to do? It's a brand new idea, or?
Well, we have customer asking for how they can have, for example, a browser and a Flutter in the same device, and things like that. And this is where container comes up and help a lot. And also, most of our customers is using containers for developing as well, because it gives you the ability to isolate it from the base operating system, and then you can keep updating your base operating system moving forward and get always the latest version.
Nice. What else are you talking about here at the booth?
Well, let me see. We have, like the video I was showing before, show all the 30 minutes getting started you have. Like, so if you come by the booth, we can give you like in 4 minutes how is the first half an hour playing with Factory in 4 minutes, like it's accelerated video. So basically, we are showing these and all the problems we have that Ian already covered today.
All right. And the three
stations is basically the same. So it's more station so we can help more customers.
And what kind of discussions do you have here at the Embedded World? People come and are very interested to get started.
People who are working with Yocto and they always need like over-the-air updates and security. They come by and say hi and try to understand what we offer. And basically, most of the conversations around Yocto, around security, around container as well, and that's more our focus. This is why.
Cool. All right. Thanks a lot.
Thank you. Thank you very much.
Thanks.
Embedded World 2023. Here at the Toradex booth, my name is Daniel Lang and I'm the Chief Marketing Officer for Toradex.
You have lots of stuff at your booth.
Lots of stuff, yeah. So here, our droid, it's tracking your face, so it's watching me, you know, say hi, and we did that with our Maven kit. So it uses our System On module with the Verdin IMX8M Plus, which has a neural network processor. And we integrated that in a very nice kit, including a camera, either from Econ system or vision components. We have a very modular backplane where you can have power over Ethernet, RS485, and so on. And the whole thing it's in a case. So you can actually deploy it in a real field. So you can put it on your factory floor, on a tractor, and so on. And that's there in the head of our friend here.
It's useful to have networking, this kind of stuff?
Yes, so really nowadays everything is connected. You want to get data for the processing. All the AI is on the device. But then maybe you wanna know which products are good, if there is a criminal around or something like that. So the metadata you get off, but the processing is on the device. And this actually board and even the droid is from our partner Ozone, which have a software feature which lets you optimize your neural networks, which you have maybe in TensorFlow or PyTorch. It lets you optimize for our hardware. So it runs very efficiently on this module. And depending on the application, we can do up to 300 frames per second. So yeah, maybe we can have a look a little bit closer to the module itself. So that's just a card. So let's walk here. On the way, we have some demos from our customer. So that's from Emphasis, and that's a pollen analyzer. So they use microfluid technology to analyze pollen. And with that, you can have more productive trees and fields. So it helps growing more food without using a lot of chemicals and so on. And they're still a startup and they're very innovative. And they use our hardware, but they also use our Torizon platform, which I can show you a little bit later. But Torizon basically allows you to have a very fast innovation loop. So you can develop something, we have tools for development, and then you can deploy it in a very secure field out to the field to these devices. And they're connected, and they found every couple months, they found new ways how they can use their technology, and they can update their devices, make them more capable over time. So very similar than what Tesla is doing with their cars, they're doing that here on a scientific instrument.
So you're all about enabling very innovative stuff.
Yes, we enable this company that has a lot of PhD in that technology to build a product, because you still need embedded computing, you need Linux, you need to do security update, you need a UI and all of that, and we really help with that. So Emphasis can focus on their core competency. And then here also a device, we do a lot, automation, it's a small robot, we do a lot of medical things, and here you can also actually see what's in there. So there's our module, an Apalis module, a display, and then of course it also controls the system. And then you have a touch screen, very nice here, it's running, so I don't know, I probably shouldn't interrupt it. Maybe I can try and see what happens. Pause, continue, so you have a UI and there's also micro.
Also very innovative,
yes,
very special.
Yeah. And also even this one, you need to do updates. They use more remote offline updates at the moment, but also here we have a very secure solution, so you're not corrupting the device, you don't brick the device, because that's a no-go in a lab. Then let's go to our hardware model. Over here. Here you see an overview of our modules, and let me try to pull in our hardware product manager. Sorry, I steal So that's Simon, our hardware product manager, and he can tell you a little bit more about our modules.
So this is our portfolio of system on modules. You see 3 product families here. You see our mid-range and high-performance Opalis system on modules. Then moving a little bit to the right side, you also see the Colibris. These are our traditional system on modules from the entry level to a medium performance. And on the right side, there is the Verdin family, our latest addition, with our brand new Verdin AM62 module at the bottom. This is something we are introducing right here, launching it at Embedded World, and it offers a very competitive entry point into the Verdin family of songs.
Competitive entry point. Does that mean good price? What does it mean?
It means basically the lowest total cost of ownership. So it means if you purchase our hardware, integrate into your product, deliver it and maintain it over the lifetime, you are going to end up with the lowest total cost. So it's not specifically the lowest price of hardware. That's an important differentiation.
There's also, when I look here, it's an A72, it's a big chip, it's powerful. You do everything from powerful to smaller.
Yeah, so scalability is an important concept for us. We try to lay out the portfolio in a way that depending on your needs, you can go from the entry level and scale up to the high performance, and we provide a nice coverage for all of your needs there, basically.
If people want just one, they can go ahead. It's possible to all kinds of quantities. How does it work to start working with you?
Yeah, so we are trying to facilitate it from the beginning. We provide extensive technical support with all the materials. We have products focusing on facilitating evaluation. So you can order evaluation products that make it easy for you to wire up your hardware, experiment with the hardware. If you feel you are more working on a software level, then pick a different product which is better suited for that. In terms of availability, all of our products are long-term available, 10 years, 15 years. We have that commitment publicly documented on our websites, and this is one of the key values customers are keeping coming back to Toradex.
So if people want this, what would be the package maybe they would get?
So this is a SOM on its own. The package we would propose to take would be one development intended carrier board, like our traditional Verdin development board, which is visible elsewhere. We would offer some accessories there, and we would offer a starting package. Maybe we would select one configuration out of the many, depending on the concrete needs of the customers we would be discussing before ordering with our team.
Cool. Thanks a lot.
Thank you.
Yeah, so maybe I can also pick a little bit my favorite here. So that's Mellow. So that's one of the carrier boards for the Verdin module. You can plug it in. And that board is good for prototypes, but it's also great for low volume manufacturing. So most of our customers, they design their own carrier board, but if you only have a few hundred, you maybe just want to use directly something like that. And you can see a lot of common interfaces, extension connectors. It's very compact, so it's kind of, and it's brand new, so I like it a lot. And it's all, you can get all the resources, so you can also use that as a starting point and then modify it for your needs. If you want to have other connector or remove some of the connector.
And so basically, if you want to go from there and just do something very specific, they can start there, but then they can ask you, how do I be more specific and optimize for that?
Exactly. You can see here we have a lot of different boards, and all of them are fully open. So you can just download the Altium design files and go from there. And you can do that yourself, or we also have a partner network which can help you. So if you said, oh, I need a smaller or a bigger board, or I need different interfaces, or I need 2 Ethernet, and so on. It's very, very easy to do that.
Nice.
Yeah, so maybe have a look at some of our other demos here, just two. This is a pretty cool one. This is for visually impaired people, and that's actually a 3D. It's an Intel RealSense. And then our product is in here, and I can already feel it vibrates, so it actually detects the environment, and then it gives you here on these microphones, it's not real microphones, it's going on your cheekbones and it vibrates, and it gives the visually impaired a sense of the environment, so you don't run into stuff.
What's the resolution? They can see walls, they can see obstacles?
Yes, so
by sound, by vibration.
Yeah, exactly. It vibrates, and if you try it out, it's very weird. So you need a little bit training, and I can see. So for me, it's hard to use, but you can do that. And it's from our customer here.
Is this like in mass production?
Yes, you can go on their website and buy it.
People use it.
Yes.
And it's changing lives.
Yeah, it really helps, the visually impaired to navigate
have
better.
a high resolution. It'd be awesome if, eventually blind people can see. But
yeah, no, I think here is more like not running into things. But I'm not a specialist on this one yet. So another nice demo here is from Praktika. It's an oven and it's super fast, so you can make croissants and pizza. I don't think anything is running, and I'm also probably not the right guy, to demo it. But you can have recipes and do that. And yes, it uses microwave and heat and everything, and it's also fully connected. And this is used in some really, really big sandwich chains and coffee chains and some really big customers worldwide, and also uses our Horizon platform and our module. So here you can actually see their control unit, where you can set that. Uses Horizon, so it's connected, so they can do over-the-air updates, they can improve it. They can monitor it, what's going on, how many times it's used, when they need maintenance, so they can do predictive maintenance on it and so on. And then here you see our module integrated. And that's a good example of a custom carrier board.
Nice. It looks awesome. So there's special oven technology, and they want to do cutting edge UI for it and stuff. Right?
Yeah, not just the UI, the control of the whole oven. And we also have coffee machines and things like that doing that. Here you can see our the display ecosystem. You want to talk short? It's on video. It's another hardware product manager.
Hi.
And maybe you can really brief talk a little bit about our display ecosystem.
So you can get a pitch with me as well. So we're working on making DSI displays easier for our industrial partners. So we're partnering with multiple display providers. Today we're showing off Reverdi displays, where we are able to guarantee availability of these displays for 5+ years. Our ecosystem is made out of the standardized pinout that you can see here with the display adapter that you can add on a mezzanine, or that we integrated directly in our newest volume carrier board for Verdin, the Malo. So we work on getting that ecosystem up and running and available for our customers during this year, with an availability of more than 5 years, so that they can work with DSI as a native interface and as the primary display interface of the Verdin family.
Because when you have displays, you have to run them, you have to run the touch, maybe all the different things.
Exactly.
And it's a way to integrate it.
Exactly. So what we do really, we accelerate your time to market to partner up with this display. So they work basically plug and play, so they're easy to integrate. And then of course you also work with Crank, Qt, Slint, Flutter, and all these UI frameworks, so you can do the UI very, very simple.
Nice.
Good? Okay. Yeah, so maybe have a look a little bit on our software. Really one of the main differentiators from Toradex to other phone vendors is our software. Here you see typically we try to emulate a typical developer desk, maybe a home office. And here you can see how we integrate our software, how we make it faster. So we are integrated with Visual Studio Code. So it's a very popular, very productive, modern environment. But I think Drew, just finishing up, can talk a little bit more about the highlights. So Drew, what can we see here on your end?
All right, great. Yeah, so what we're looking at here, this is the developer desk. So this is kind of the central view of what a a software developer using the Torizon system would look like. So this is just my Ubuntu laptop with all the tools that are needed to develop applications, to develop the custom operating system, and to just generally to work with the Torizon system as a software developer. So the first thing that we have, first thing that most developers get is we're going to create a new project. So I'll just bring this window up. These are all the project template types that we support out of the box. So if you need to create a Python app or a Qt app, we have templates in place to allow you to quickly get up and running with any of these project types. So you don't have to be an expert on containers or on Linux or on Yocto to be able to start deploying your application quickly onto the device. So let's jump over here. I've got a basic Python Hello World app that I can bring up. And so as a Python developer, all I care about is my high quality Python source code. I don't need to know the complexity, like I say, of containers or anything. I come in here and I start writing my code. I'm ready to debug. I hit the F5 button. It's going to copy the device. It's going to copy the code over. It's going to hide all that complexity from me. It's going to package it as a container. It's going to deploy it to the board, allow me to do source level debug, just as if it were code running here natively on my desktop. Once I'm then happy with it, I commit it to my local Git repo. I push it to the cloud in GitHub. We have reference implementations with our CI/CD system, or excuse me, with the GitHub CI/CD system, GitHub workflows, so that when I push new changes, it can automatically be configured to do a cloud-based build to check out and deploy, say, to a QA group of devices. QA does their work, and then they push the changes up one level further. The changes then get checked out and pushed up to the Torizon platform for deployment to the entire production fleet.
You think most developers will use the Visual Studio? Or they can use other?
There are probably, I don't know if it's 50-50, there are some people that are used to Yocto, used to a traditional command line. Maybe they're coming in with some code and container setups already that might not use this directly. They might use it for inspiration, but anybody coming in that's, say, coming from Windows CE or some other environment that doesn't know this environment, those are the people we are really targeting with this Visual Studio Code extension.
And you support a whole bunch of platforms, people prefer that or this, they can work with what they like.
Yeah, in fact, those templates that we showed at the very beginning, the idea is that they're easy to generate. So if you have need for a specific application type that's not supported by our templates, it's easy to create a new template for your specific framework or whatever it might be.
Cool. Thanks a lot.
Right, so now we talked a lot about the developer experience, so let's get a little bit the bigger picture overview. And for that, let's go to our wall here. Here, I take this here. So here you can basically see the overview of our Torizon platform. So before we withdrew, we were actually at the developer location here. And there you could see the Visual Studio integration, and you can also see that we have our Torizon core offering. So that's the basic Linux. It's Yocto based Linux, fully open source, and you can use that, pull that in, and then, for example, you need a Qt or a Codesys or a Crank or AI, and that's all provided as a container. So it's very easy to integrate. And then, as Drew showed here on the Visual Studio place, that's integrated. So you develop like you would develop on a desktop. And why did we do that? It's really to make it easy for people coming from Windows CE, web applications, and so on. So they can easily move to an embedded device and can be very productive. Then we have a very secure way to deliver your software to your end devices. And we use a framework. The whole thing we call Torizon, but the framework below is Optane, and Optane is very secure. It's actually built for state-level attack, and it's commonly used in the automotive industry. And then also we have a way back to get information like device monitoring, remote access, and so on. We see that here later. And then we have fleet. So most of the demos you see here, the brewery and the agriculture and the medical and the beer and the coffee machine, they're all connected. And maybe I can show you that here. I can give you a very short overview. So that's our control panel. So for example, before we were at the oven, so you can here see what the oven is doing, how many recipes they process, like the current, the CPU. I think you can also see the preheating thing, if the door is open and so on. So you can use that for predictive maintenance. You can do remote offsets, you can push OTAs here and so on. So
it's all about security?
Yeah, so there's a lot of security and we have our security expert here, and maybe let me just try to steal it. John lead our Horizon platform, so the stuff in the cloud team, and he's also our security expert. So maybe you can talk a little bit about the security philosophy behind the Horizon platform.
All right. So I would say if there's something that defines the philosophy we take, it's that we try to do the hard thing first and then work to make it easier. And especially when it comes to security around software updates, it is a topic that can sound simple when you first look at it, but gets just devilishly complex and has a lot of implementation pitfalls. And if there's one thing that I would like people to know about software updates, I think people usually start with an assumption that, hey, if I sign my updates, I'm fine. If I worry about some transport security and I sign some updates, I'm going to be okay. And that is an attitude that tends to work well until it really doesn't. The core of any software update system is actually about securely communicating repository state from your remote repository that can attest the validity of software you have to install to the device in a secure way that considers the timeliness of updates, that considers the pertinence and compatibility if you have a multi-ECU update scenario. And actually dealing with all of those things and working with all of those edge cases is genuinely a devilishly difficult prospect. So my background, I worked in the automotive industry for quite some time, working with safety critical.
And usually cars, you can just click, you log into them, you can hack them like in 5 seconds. That used to be like that, right?
I would say that is something that very much woke up the automotive industry. I mean, the famous G-Pack in I want to say 2014 really marked a turning point. And in fact, that was a big part of the impetus for the Uptane project, which was when the automotive industry essentially got together to figure out what should we do to worry about update security in our vehicles. And they contacted folks at the Secure Systems Lab at NYU Tandon, at the SSRI Institute in Michigan, and developed an extension to the Update Framework, which is a cloud-native Computing Foundation and Linux Foundation project that is kind of the gold standard for software update repositories, and how you would extend that for the automotive case where you need to have central direction and control of updates, you need to update secondaries. And so the development of that standard started in 2017. I worked pretty closely on it. Toradex ended up recruiting me because they were interested in that system. And our update system at Toradex is now based on the Uptane standard. So we deliver updates signed with 2 independent chains of metadata, one that attests software validity and timeliness and consistency and all of these guarantees, and another independent metadata chain that attests the actual installation instructions. And I mean, you can probably tell I'm pretty passionate about software update security.
So the Horizon has the full security, the secure updates forever. When you have all these cool devices, potentially they could be updated forever, stay safe, and it just works?
Yeah. So this is the thing that I mentioned. We try to do the hard thing first and then make it easy. So when you get to the really hard questions about repository state, it turns out that practical research on flaws in software update systems, often what it comes down to is flaws in key management. And another common mistake that you see in update systems in the wild is thinking that, okay, I have a PKI management system. I can manage signing software updates with my existing X509 certs. I can do it with my centralized key management system. There are some special needs of software update systems that demand some difference in how you deal with that. So one of the things that's built in from the start is the ability to rotate keys and sign changes in the trust relationships of the repository. Which is a long way of saying, when you start up and you sign up for a Horizon platform account, you connect your devices to it. You can see here we have some actual devices connected. Those devices, the root of trust, is actually managed by us. It's online. You can click to update a package. You can click upload a new software binary, use our tools, whatever. However, you don't want to have a single point of failure in a software update system. What if you have a developer who left credentials to this system on a sticky note? What you can do for your devices in production is take all of your signing keys offline, so that when you are ready to do production releases of software, you can have a prod repository that has an extremely limited set of software, that there's only these specific versions which get secure attestations from the device of exactly what software is running. Only these ones are authorized. And it doesn't matter, even our developers, even if you had complete access to our systems, as long as you have those keys, those important signing keys offline, well, you are fundamentally safe. And the pitfall that people get into with signing offline, and I think that a lot of people who start rolling their own update system with Rauk or SW Update end up with troubles with the signing keys. You lose a key, it gets compromised, somebody loses it. What is your strategy for rotating it effectively on the device? And our software update client handles that automatically, transparently, which is what lets you start with an online key and then roll it offline without pain.
That sounds awesome. So hopefully maybe you have 100% security support eventually. It's difficult, but...
I mean, you can see we're really thinking a lot about it. We're spending a lot of time. We choose like the hard way a little bit to make it easy for our customer. And we're not like, a lot of people would say is it overkill for what you do, but we are not doing consumer grade IoT. So we really do critical devices, we do medical devices, we do industrial. So if something happens, the damage is huge. So that's the reason we go that way. But,
you care about
and
about
the thing
your
is,
platform.
yes, and we know all about that and all about the thing to make it easy for our customers, so they do not need to have all that pain themselves. We go for that, and we have people here who love the pain to go through that and make it easier.
Horizon keeps improving.
Yeah, of course, yeah. I mean, this is the thing, right? So like a lot of our customers, they choose Horizon so they can update their system, but of course also on our side, we need to, keep an eye on everything and, update it and get better. So like maybe one last word, so we talked a lot about security, which is extremely important, but the other thing our customers really care about is reliability. And for that, really brief, so we are actually very confident about reliability, and we just switched the demo here. But you can actually come here, so if you maybe at the next show, we have here a demo, we say like try to break it, so you can actually try to break our ODR update system. You can pull the power, you can have corrupted files, you can play around and you can win a USB power bank if you do that. So now we're actually just switching our demo to our partner from BlackBerry. QNX, so we're also working with QNX as an alternative software offering on our system. So I don't know if you want to short talk a little bit about what you did with Toradex and how you support our models.
So today we have planned a short demo for QNX running on the Toradex Opalus board, and we will just show how you can get QNX up and running on the Toradex board and show a few of our demos and profiling options with our IDE. So that's.
Have anybody been able to break it?
So that's the order. Yeah, so that's still about Horizon. So Horizon, it's break it. Bruno, did anybody break it?
No, not yet. Hopefully someone can break it, so we find a problem we can fix, but no one yet.
Are there good hackers at the embedded world?
Maybe.
Maybe.
Walking
around?
Walking around, not here apparently.
Yeah, good. Yeah, so I hope you could learn a little bit about our products and our presence at Horizon, about our customer. And we hope we can work with you very soon, and see you again here.
I think you probably have a very fun job working with all these amazing, interesting projects people have. With you talk about PhDs, they have all this science, all this knowledge, and they want to turn it into a product. Yeah. And you are there to help them.
Yeah, no, that's really one of the coolest part of the job. And we also look for new people, so you can really work with very innovative companies. There, for example, we have 9T Labs. They do continuous carbon fiber 3D printing. We are in satellite, hypercars, supercars. Yeah, like PhD doing new micro thing. We have people using ultrasound to split DNA. A lot of
wheelchairs.
We have wheelchairs. Right? Yeah, we're really helping people. That's also very nice, right? We do a lot of medical devices which really help people. A lot of people getting older, so we have a lot of connected devices helping them. Emphasis, we helping generate more food with less, chemicals. So it's really, really cool to see what all these customers do. And we have over 3,000 customers worldwide. So it's a very exciting field to work.
And the order quantity can be from very few to...
Yeah, so our products, they're used from a couple hundred to a couple 10,000. So our very high volume customer maybe have 70,000 devices a year. Our very low end customer maybe have 100 devices a year, and we do everything between. If you go very, very high volume, we can support you to do a design in. So maybe you only have 10,000 pieces at the beginning, and then you ramp up, we can help you. And of course also on the low end we have very good support. We are very famous for our online resources. So even your small company is very easy to get started.
So not only the universities in Switzerland, but anywhere in the world, if they have some amazing idea and they're thinking how to get it done, to just start contacting you.
So we love to work with university for, a lot of them, creating startups, have smart people, or they go into companies also for recruiting. So if you are in a university and you need any hardware, contact us. We have special, you can get free hardware, discounted hardware. We have programs, we collaborate on studies, master theses and so on. So we love to work with universities.
And how's it going in Lucerne at your headquarters or the different offices? Is more and more...
Yes, we are...
You hiring?
Yes, we hire. You check our website. We just went to a bigger office in Brazil, in Campinas. We have a very nice new office. We're just going to move in Seattle to a bigger office. The office in Switzerland is growing, so it's going very well. So very happy about that.
Cool. Thanks a lot.
Thank you.
Thanks for the tour. please introduce yourself.
Hi, my name's Robert Day. I'm with the ARMS Automotive Division. And what I'd like to talk a little bit about today is an initiative called SOFI, which is really aimed at enabling the software-defined vehicle revolution that's coming.
So what is a software-defined vehicle?
So a software-defined vehicle is essentially the features and the functions of the vehicle, and often the differentiated features and functions will now be driven by software. So it gives the opportunity to kind of design how a car's going to feel and how it's going to operate by software versus, traditional hardware modules. So it allows the automakers to basically decide how to keep their car updated through software. Okay.
What is SOFI?
Aha. So SOFI stands for Scalable Open Architecture for the Embedded Edge. So it's an initiative that we kicked off about 18 months ago, and it's really looking at how you can efficiently develop software and then deploy that in a vehicle. So what we did with SOFI is we looked at what other industries do agile development and deployment of large amounts of software. And so we found that the cloud and cloud development was a really good starting place for us because people do that every day. So you develop in the cloud and you basically deploy to a cloud instance. That's what cloud development's all about. In this case, instead of deploying to a cloud instance, we're going to deploy to a vehicle. So we're using these cloud standards, cloud tooling, but what we do is we actually look at how is a car different? How is the software in a car going to be different? A couple of things are, one, it's real time. We need to worry about real time stuff. We need to worry about safety, which you don't have to worry about in a cloud instance. So, okay, what do we need to do to these standards or to these tools to make them work for a car? So you'll often hear the term data center on wheels for the next generation of vehicles. The trouble is it's not a data center on wheels. The compute might be similar to a data center, but the software that's going to be running and what that software needs to do is not going to be the same as a cloud instance. So that's why we came up with this initiative. When we kicked it off, we wanted to make it an industry initiative. So we got a group of companies from both the automotive world, but also from the software development world, because this is a software development thing. So the governing body members of SOFI are ourselves, Cariad, VW, Woven Planet, Toyota, Bosch, Continental, from the automotive industry. These are the companies that are going to be essentially adopting things that we put together as a SOFI architecture. But we also brought in people who understood cloud and software. So we also have Red Hat, SUSE, and AWS as governing body members. So there's 8 of us that are really kind of looking at what does this need to look like to make it work for software-defined vehicle. So it was quite a long answer, sorry.
When you talk about the AWS, Red Hat, all that, they do a lot of stuff in the cloud, and now they can, all their skills, they can put it towards cars.
They understand development in the cloud, they understand software development. All we're saying is we need to look at it going into a vehicle than going into a cloud instance. And so they have those skills for the large amount of code, software code that's going to go into a vehicle, that sort of development, that agile development. There's a term we use in cloud, CI/CD, which is continuous integration, continuous delivery, because that's what they do. They keep integrating, and then they deliver. Our vehicle's going to be the same. When you buy a car, a software-defined vehicle, that vehicle will get updated. And when it gets updated, it's going to get better. So no longer when you drive your car off the dealership, does it get kind of worse over time? It's going to get better. It's like our cell phones, that we get new versions of operating systems, new tools, new applications, updates, upgrades.
And it's not just the UI of the infotainment system, it's actually all the way down to the wheels.
It's everything. And the market is changing as we go into things like electrification, where people are just redesigning the vehicles to be EVs. So you've got a clean slate, you can really look at all of the, you know, the functions, the electronics in the vehicle, and you're almost starting from scratch, which is great. And so this initiative is really there to try and sort of like enable this and accelerate this.
And behind you, are you showing a demo?
Yeah. So let me explain this. So one of the things with SOFI is we wanted to have applications within SOFI to show the automotive developers how you would use SOFI to develop a particular application. So this is running something called AutoWare, which is an autonomous software stack. Okay. Yeah. We're actually running it on this system here. Okay. And this is a system that we had a partner company, AD-Link, develop, and it's called the AVA Developer Platform. So it's basically got a powerful ARM processor in it. It's a 32-core ARM processor, because we didn't know what people would want to develop using this. So we kind of over-provisioned it so that you could run any software-defined function, including an autonomous stack, which is what we're running here. So what this is really trying to do is to show how you could do your development.
Which CPU is it?
So it's an Ampere Ultra 32, which is 32 core.
And it's got a nice cooling.
Oh, it's liquid cooled.
It's connected with GPUs.
Yes, so this is running GPUs as well. So a lot of the functions in these high-end automotive systems like autonomy, they don't just use CPUs, they use GPUs, they use accelerators. So this system's actually expandable. It's got 3 PCIe, so you can plug in graphics cards, whatever you want, networking. So it's really quite a nice system to get started. Because as I say, we don't know what people are going to develop on it. We're hoping the whole car, the different parts of the car, and part of the SOFI architecture is also looking at how you can have different applications running on the same system. So there's no reason why you couldn't have your ADAS system and your IVI system running on the same compute system if it was powerful enough.
What am I looking at here? Is it to do with self-driving and stuff like that?
Yeah, so AutoWare is an autonomous self-driving stack. So this is just sort of showing a view of what AutoWare sees. Obviously we're not connected to a car, so we're showing an example of one of the parts of AutoWare, showing the point cloud and what it's seeing from the sensors. But this is a kind of pre-recorded sensor stuff because we don't have a car here. But at least it gives you an example of what we can run using the SOFI architecture and using this development platform.
It's quite amazing the ARM processors people are developing for self-driving cars and electric cars and everything. And the power they have is amazing, and it keeps getting better. Yep. Actually, you can even swap boards out in your car to keep it updated.
Yeah, so it's really interesting when we're going into this software-defined world. Okay, there are a couple of things. So firstly, what SOFI is trying to do is really take away the real dependence on a particular hardware system. So you're right, you could move from one SoC to another SoC, whatever, or if there's a newer version of the SoC, you could do that. Okay. The other interesting part is you could like we did with this thing, the automakers could over-provision. Okay. It's not what normally happens, because normally you build it to what the car's doing. But if you're going, well, I think I'm going to have extra functions, I'm developing those as an automaker, and I want to maybe upsell them to the consumers of my product, put a bit more compute power in there. And that will be an interesting shift in how automotive works.
Yesterday I did video with they were talking about 128 core in the car.
Yeah.
Like you could have the bigger SKU.
So this one you could actually put 128 core in it if you wanted to. So it's it's a COM HPC module that we put in here. So it's upgradable even in this development system.
And here it's showing the.
So this
we're talking about.
Yeah, this is the architecture of SOFI. So there's a cloud part. This is where you kind of do your development using the SOFI framework in the cloud. But obviously this needs to get deployed into a vehicle. So there's a sort of similar view in the vehicle. So up here, you basically start developing your code. You're developing in the cloud. You can even do your testing in the cloud. You can do things like digital twins to kind of like get a good representation, even in the cloud, of what your vehicle system looks like. And then what we're doing is we're using some cloud technologies like orchestration, which allows you to then deploy your different workloads, which are shown in the kind of green boxes here, down into the computer on the edge, which is what this is sort of simulating right now. And so another part that's another technology or methodology that's used in cloud is containers. So containers, again, allow you to develop these workloads, these applications in the green boxes there, and then sort of seamlessly deploy them from the cloud down into the edge.
I guess it's working very fast, this ecosystem. People are asking for this right now. There's so many electric cars coming to the market right now. Many of them want to be self-driving.
Yeah, so the different applications, it's all going to be driven by software. So you're right, there's an appetite for it. So the SOFI members, we're now over 70 announced members. So there's a lot of different people in the automotive ecosystem that are really getting involved with this initiative. And it's got some really good momentum, and it's because there's kind of a need for it out there, and there's a desire to start developing software now, even if the vehicle's not going to be produced until whenever. I want to get my software development going early, and then I want to be able to continuously integrate and continuously deliver.
And here at the ARM booth, you have more different demos talking about this?
If we go around the other side, yep, we can. This is an example. This is not actually running SOFI. This is just this is one of our SoC partners. So Telechips. I think this was announced today, the Dolphin 5 SoC. And so this is kind of cool because it's running different applications that you would see in the cockpit on a single SoC. So we've got an example of running a movie. We've got an example of sort of surround view and surround view camera. So there's a camera here, you can see my hand. So they got cameras all around this to do the surround view. And then you've got your cabin functionality over here. So it's basically showing the power and the performance of this SoC, which we can see here with our Cortex A76.
High performance. 8 nanometer.
Yeah, so this thing's rocking. I mean, you can see this display here. This is running on this SoC. It also has our Mali G78, which is a GPU, and it also has our NPU in there as well. So this is a really good example of the different types of IP that ARM produces that can be used by our silicon partners. So this again is showing how you can run different applications on a single compute platform, a bit like we were talking about around the other demonstration. This is just showing it in a very graphical way.
For a while I've been seeing such amazing ARM processors, but it's hard to see all the potential actually used in devices, and a car is a great way to do that. Because you have so much stuff going on.
Absolutely.
And you want to process all of it at the same time.
Yeah, and if you think about a vehicle, there are so many different systems now running in a vehicle. I mean, this is just showing what you sort of see. But yeah, this is showing your cameras around your car. It's showing potential for sort of, ADAS functionality, display functionality. And so, yeah, it's a really good way to see, quite how performant these things are right now, and also the sort of software applications that run on them.
Cool. All right, thanks a lot. Thanks for the...
You are welcome.
The tour. All right.
Okay.
Hi.
Hello. My name is Torben. I'm from Pyramid, and you see here our products from Phytech and from Pyramid.
And you say Pyramid?
Yes.
It's not Pyramid?
Yeah, it's Pyramid. If I pronounce it in English, then it's Pyramid.
All right.
No, but we are a German-located company, and it is called Pyramid.
And right here is a big touchscreen. What are we looking at?
We're looking at our first outdoor kiosk, a full outdoor kiosk with the touch display from Phytech, our company. You have a display which has 6mm glass, so that it's really robust. And you have a solution for ticketing, for example.
It's it's very good display, high quality.
Exactly.
The best touch manufacturing.
In Asia, exactly. We have a display with 2,500 nits, and as I told you, a big glass so that it didn't get broken.
Even if drunk people are around, it's okay?
Exactly. If they take their beer and throw it again against, it wouldn't break.
And then you implement a whole kind of smart stuff behind.
Exactly. We have a scanner inside, we have a printer inside. We could also use a A4 printer for ticketing for railroad, for example. We have a payment system, but we can do what the customer needs. So we have, for example, a payment inside. We could also use different.
Is this
versions.
the VIP machine? Is it a bit expensive or? Depends.
That depends on what you think what is expensive. We have a solution for outside, so it's full outside. It's a little bit more expensive than the inside version because you have sunlight, you have rain outside, and we have to do it IP65 conform.
All right, what are we seeing here behind you?
On the left side we see our new stripes. This is for digital signage. We have a special design. We named it Stripes 48.5 inches, where you can put different content of advertising. For example, we had a customer from ice cream, and he told us that he could do all his ice sorts on it, like strawberry, pistacia, hazelnut, and so on.
This is also manufacturing the Phytech?
Also manufactured by Phytech, but here you have no touch display. This is only for digital signage. If you want to see a touch display, a little bit bigger one, we have it on the left side. This is our 55 inches touch display, 4K.
It's 4K.
4K, and you see here our solutions, the Pyramid world. Here you can see where we are located, in which business we are located. For example, burger stores. We have the possibility to do digital signage at the beginning of the store with our A-frames, also from Phytech. And we have the solutions like our kiosks, where you can order or where you can buy the burgers and so on.
This is a very nice 4K touch.
Exactly.
The highest quality, viewing angles.
Exactly. It's always optical bonded, so it's a little bit more brightness, and you don't have an air gap inside, so it cannot be getting rubbish inside. So.
Nice. And what else do you show here at the booth?
At the booth we also show our industrial PCs. On this side we have the 19 soil racks. Like this one is the KI version. We have our 19 soil racks with front I/O on this side.
So what people use this for?
For servers, for example, safety relevant technology. We are using this often for storage, for example, and machine vision or industrial machines like CNC machines. Also on this side we have the back I/O version, and here we can see that we have also possibilities to make individualization for customers. For example, a logo for the customer or different kind of colors.
And what's happening here? There's another Phytech display.
This one is another Phytech display. It's a full outdoor A-frame, we call it. This is also digital signage, so no touch. It's for customers who can put their content like commercial on site and get the customers into their shop. So this is also in projects. We have it with a EQ system with battery, and you can put it in malls, for example, and say, hey, go to this burger store and buy our burgers and so on.
And then you charge it at night and you put it back.
Exactly. This is the idea of it.
You can roll it on a couple of wheels.
Exactly. You can take it, no, not on wheels. You can take it and put it
not
outside
even
at
heavy,
the beginning
maybe.
at the opening of the store. Yes.
Nice.
And the last one you can see is here. We have our small touch display from Phytech. In this time we have a 7-inch touch display with cover glass with 7H, so it's robust and very small. And the bigger one you can see here, for example, the 12-inch 0.1 version, HMI open frame, where we can, for example, use the Siemens SPS with our display, with our panel PC.
What is this?
This
SPS?
is Siemens SPS Steuerung in Germany, we say. So this is used for different kind of machines to use or to control the machines, and our panel controls the Siemens SPS.
So people can put that in their factory or something.
Exactly. You can put it in your factory, in your machines, and you can control like we do here, light on, light off. Only a small solution for what we can do.
Nice. And down there?
On this side, we have our box systems, different kind of industrial PCs. And on this side, we see our rubber frame. So this is a rubber frame capacitive touch display for 10-inch and 50.6 inch. Our range in the displays go from 7-inch to 55-inch in a normal way, and we could do bigger or smaller if customer needs, especially.
Nice. And this one looks very bright.
It is very bright. We have here again optical bonded, and the big thing here is you have a very small frame, very small.
Touch.
And it's touch again. We have always touch. You can see here our solutions, for example, in the center, in the data center, where we have our touch systems. And the last one, what I would show to you, is our rugged size, our rugged display. This one is with a 6mm glass. It's rugged, so you can throw something against, and it's also, if you see it, it's also so closed that it is IP67. So there's no possibility for water or for dust to come inside. You can go swimming with it, and you can throw it
I'm scared.
on the ground, and nothing did happen.
Cool. All right.
Yeah.
So this is a big next step of the future, the Phytech Pyramid joint company, right?
Yeah, we are a joint company, and we grow together at the moment, and it is very great because our industrial PCs and our displays grow together to our self-order kiosks, for example. So we can use both technologies for our self-order kiosks.
And you based in Germany?
We are based in Germany, in Freiburg, and have different factories worldwide.
And Phytech is in China?
Yes, Phytech is in China. The factory is in China, but we have storage here in Germany, and our sales guys and our headquarters in Germany.
So anybody who has big ideas with touch and everything, you're ready?
Of course.
Work with them.
Of course. As I told you, we are a manufacturer for what the customer needs. And if someone came to us and say, hey, we need, for example, the transparent display. If somebody say to us, we need the transparent display. It's also touch. You can see it here. It's a touch display where you can see also behind the people and everything what is going on. If somebody wants this, we also can develop this.
Nice. That's called OLED touch monitor, transparent 55-inch.
Exactly. 55 inch is only one solution. We could do it smaller if the customer needs it.
You can do 100-inch? Well, depends.
100 inch. I think at 84, 85 it would be
maybe
the ending. And not for transparent, for normal touch displays. It would be the limit, I think, at the moment.
Thanks a lot.
You're welcome. Horror.
Or maybe even would you like to talk about 5 billion?
Hi, please introduce yourself.
Hello, my name is Anton Kuzmin and I'm responsible for all the development efforts here at Aris Embedded company. And one of our most recent development and partnership is with the new Renesas chips.
So this is the RZ, what do you call it? The V2L? Maybe?
V2L is not this particular chip, but we have it on the other design. Those are RZ5, based on, so it's a microcontroller chip, embedded controller, built around the RISC-V architecture, based on Andes Semiconductor RISC-V core. And recently we introduced this SGET standard OSM module, built around this chip, and a new development platform for this model, which is a 5-berry. It has this chip mounted on the Raspberry Pi form factor board, so you can easily prototype all your designs with this chip and use it for development with the
Does it work?
chips. Yes, of course.
So it's actually running there?
This demo is running on the other Renesas chip, a bigger one, RZ V2L, and it's a nice one. Yes,
an ARM.
Yes, it's a dual-core ARM CPU with their video processing unit and also artificial neural network accelerator chips. And you see here the demo running the YOLO neural network with their image recognition and identification. So it runs the streaming video from the USB camera through the accelerator chip and image recognition neural network, and then shows it on the display with the bounding boxes and everything.
Nice. What is this?
This one is the same standard family as OSM. It's a recent SGET family, but these boards are for the different CPU. It's also ARM architecture, but a little bit bigger. So with SGET OSM standard, we have a small size, medium size model, and also a bigger size models are
What is the
available.
architecture of this CPU?
Those are ARM. It's from ST Micro STM32MP1.
All right.
But
that's running on Linux, for example?
Or
running
yes,
Android?
Yes.
Yeah.
And this one is running Yocto Pro distribution, Yocto Linux. And we do support different embedded Linux distribution on all our products, and that's Yocto, which is an industry standard, but for the easier start for somewhat lightweight distributions, we also support a build root.
Nice. What's happening over there in the booth? You have the big wall that says, that kind of lists all the stuff you do and shows more and more boards.
Yeah, above you can see almost all the keywords or the services we are providing, but here on the display we have a nice product line. We have starting from the different system on modules based on the CPU, different CPU architectures.
So what are we seeing here?
Those are Atmel small ARM CPUs. Then we have NXP IMX8M Mini. Then we have NXP IMX6UL, an older product. Those are even a legacy products, but they are here to stress that we support for our industrial customers. We support longevity, a lifetime, 15 plus.
15 years.
For many products, for some of them we can see later on, we have even 20 years of lifetime.
Which one is 20-year-old?
Not 20-year-old, but with a guaranteed lifetime for 20 years. Those are microchip Smart Fusion, not Smart Fusion, PolarFire system on chip FPGA. And that's interesting that it has a combination of the FPGA matrix and hard CPU core, quad-core RISC-V architecture. And all those modules are running also...
RISC-V running on the FPGA?
No, RISC-V running on the hard processing core on the same chip with the FPGA.
All right, that's fully deployed, fully working.
Yes, absolutely.
Right.
Support for those modules is available both from our meta layer for the Yocto and also upstream to the mainline Linux kernel and to their microchip repositories. So they are not only fully running the Linux distribution, but it's also all the changes upstream. So we do contribute our hardware support for our hardware to mainstream Linux distribution.
Your company is around the world?
We are located in Munich area, but customers we have quite a lot of customers in the States.
And you support everywhere?
All around Europe, Japan, some China and Indian customers recently, Israel, so all around the world, I would say. Maybe Southern America is not that visible on our map, but generally, yeah.
Working everywhere. And people who have projects work with you, and you work together to get it done.
Yes. Yeah, right. And we are not only selling our modules, we are providing services to help our customers to design in our modules. And also, if some customers have specific requirements or if they need some custom development, we can develop modules for them, a system for them based on their requirements and the technologies we own. And also we are trying to participate and to a partnership with both semiconductor vendors as Renesas is. We are a design partner of Intel, design partner of Microchip, and we are trying to participate in promoting those products. So in MIV Summit, it's a Microchip event. We have webinars and trainings together with Aero Semiconductors and later on an FPGA Congress presence. So quite active on promoting those projects and products as well. Just because many people are still somewhat scared of their FPGA technologies and especially in system-on-chip FPGAs because such projects involve their expertise or require expertise both from the hardware design side, from the FPGA development, and at the same time from the embedded software development. And what is the strong point of our company is that we are capable to provide an integration of all those technologies. We know all of them, and we can help customers and willing to help customers and educate people that those
FPGAs have a lot of potential. You can do anything you want with an FPGA.
And they see a lot of development recent years, and yes, we are very enthusiastic about it. And
especially when you want to have long-term support, you can potentially make things work longer and longer.
Because you can update, effectively you can update your hardware without updating your hardware. You can provide a new functionality, extended functionality, and change it. But what is good about them, both now Intel and Microchip support that they do guarantee a lifetime of 15 or even 20 years for them. Products. And we believe that Microchip, Microsemi have not obsoleted any single family. So some of their chips are selling for more than 10, 20 years already on market. And that serves as a good promoting point, especially for the industrial customers, for the customers in the embedded area. Because the design cycles are relatively long. It takes another 2 to 5 years to design in something, and then you are not going to change your hardware platform for another 10, 15 years. You just have to use it and have to have a supply, have to manufacture your devices.
Cool. Thanks a lot. Thank you.
You're welcome. If it's something suitable, or you can make anything out of it.
Yeah. Okay.
So actually,
So maybe it looks cool in the beginning to start here, but if you want to start with the stuff over there?
Yeah, sure,
or-
sure.
Yeah. So maybe we just start here to introduce, and you say, welcome. Maybe if you just do a little bit there, just shake it for a little bit. Yeah, because my video is going to be in 4K. Right. So I'll do it like this, and then you can say, hi, my name is, welcome to Embedded World 2023, our booth here. Okay, stuff like that. And I'll try to ask you questions.
Okay.
Okay.
So is this like a live broadcast or?
Yeah, so
Okay.
right now it's live.
Okay.
Yeah, but I'll record, so I'll publish it in 4K after.
Okay.
Okay, let's start again. It just can be cool. Like when I do like this, you can say, hi, my name is, and then introduce yourself. And okay.
Hi, my name is Frank Chen. I'm the CEO and CTO of Exoscene. So we want to welcome to you Embedded World 2023.
And what do you do at in the embedded world?
So we are a storage provider. So we do full service custom storage for industrial, aerospace, automotive, and cinema. So we're here to showcase our storage products.
And it's like high reliability when you be in industrial products. Flash storage is a great way to do industrial.
Yes. So compared to traditional HDDs, where they're kind of perceptible, they're susceptible to vibration, shock, different air pressure. So SSDs, flash, they're completely made of ICs, so they're not susceptible to any shock and vibration, any thermal issues, any altitude issues. So this is where we build high reliability storage.
So what are we looking at here?
So what we're looking at here is an industrial grade solid state drive. So this is our own custom design, where we design all of the hardware, the firmware. We do all the testing internally. We do all of our own manufacturing. It supports up to 8 terabytes and very low power. So compared to a traditional HDD, where you see like a 3.5 inch HDD, that's about 4 to 5 times the size of a 2.5 inch. We can store much more capacity. It's got a much higher storage density compared to HDDs.
Are there algorithms you can work on to make things more reliable and the data to be safe,
yes,
no matter
Definitely. There's basically we own all of the firmware, so we develop all of our hardware and we write all of our firmware for SSDs. So that includes several important critical components like flash management, data integrity, and data security. So we also implement RAID functionality on our SSDs so that we can recover data in the background transparently in case there are data corruption or something happened to the data.
What is the whole process of getting data out of a broken device or device that has issue? How does it work to recover?
So most of the vendors will tell you that you cannot recover data from a broken SSD, which is
quite incorrect, because if you own all of the base technology from the hardware to the firmware, then you should be able to recover the data. So in an event, something like this, the data needs to be retrieved from this, maybe something hardware, there's some hardware issue with this drive, we take apart the case and then we'll actually connect the driver with our debugging tool. From the debugging tool, we'll be able to reinitialize the drive and initiate the drive recovery process.
And you sometimes include that?
Yes.
As part of the service?
Yes, we include data recovery as part of our differentiated service because we're able to go much more beyond file system level data recovery, going to hardware level data recovery and firmware level data recovery.
And you have data recovery around the world?
Yes, we support this by either remote recovery, or we can have FAE on site to do the recovery, or you can send in the device to us. We can do a factory level data recovery.
And there's many different kinds of storage that you do, huh?
Yes. So for industrial, we have various form factors. This is a 2.5 inch, which is optimized for thermal. So that means you can operate without any thermal solutions or like fans or air flows to cool off the drive. It'll be able to run at full speed at 85 C. Okay. So these are M.2, 2280, 2242, and 2230. So they don't have a casing. So additional thermal solution needs to be applied, and we work with our customers to come up with the most optimum solution for thermal mitigation. In addition, we also have our firmware ATC algorithm, which automatically adjusts performance to ensure that the drive operates at an optimum performance in any thermal condition.
Because these kind of storage products can get pretty hot.
Yes.
It's one of the things, sometimes I touch the SSDs and stuff, it's pretty hot, and it's a challenge.
Yes, it is.
To design things correctly.
Yes. So really, it starts off from the component. We don't sort commercial flash and build them as industrial grade. So all of our components are industrial grade. So we buy industrial controllers from our SSD controller vendor. We buy industrial grade flash, and we also package our own industrial grade flash.
Because sometimes the amazing magic factories that kind of make SSD, NAND, and all this stuff, they also have patents on certain ways of doing things. And you can use those or do differently, customize the way the algorithms are designed.
Yes. So basically, we have our own patents on how we manage our flash, how we optimize our performance. So we filed over 70 patents worldwide on our SSD technology.
Nice. And you're tightly collaborating with the R&D of the next gen, I guess.
Yes.
Because the way you design the memory, you have to think about firmware early, about how you want to design it, right?
Yes. So we work very closely with our controller vendor, which is Marvell, on their next generation, on their future roadmap controllers, and we work very closely with the NAND flash vendors like Kyocera, WD and Micron, Samsung, and Hynix.
And do they sometimes collaborate with you on the end product, like even they might use themselves as separately? Or you only keep your expertise for only your brand?
We're open to collaboration, but mostly we do our own, but we collaborate with a lot of partners. They're not necessarily flash vendors or controller vendors, but we work with partners like NVIDIA, Mercedes. We work with partners like QNAP, to help them build and help ourselves build ecosystems for storage, for flash storage.
People buy a self-driving car or EV or some cool products, I'm not going to ask exactly what, but they might be your storage in some of the cool products in the world.
Yes, some of our storage is in some of the most unexpected places for high performance and high capacity applications. So it could be somewhere, flying in the air. It could be
in space.
Maybe low orbit satellites. Airplanes. Underwater exploration, oil and gas, automotive, industrial, medical. You name it. We're pretty much in there.
So all these guys developing cutting edge things, they know how to contact you and say, hey, I need this performance, and you might be able to provide it.
Yes, and not only that, but not only do we do cutting edge, we also do trailing edge, because our goal is to serve our customers, no matter what their needs are. So as long as we're able to provide differentiated service, whether it be performance, capacity, power, or security, or any other features that our customer want, we're happy to implement for them and support them.
Nice. Can you show some of the other storage products you have here?
This is a unique product that we have. It's the PI4 Series E1.S. So it's the first of its kind. It's an enterprise form factor storage, but optimized for industrial and automotive applications. So for industrial, it's -40 to 85 with encryption, TCG OPPO, and for automotive, we actually added conformal coating and we added BGA underfill so that it's shock and vibration optimized, and it's protected against the elements like salt, humidity and things like that.
So this could be in some amazing cars,
or airplanes,
or boats.
Yes,
all kinds.
Yes.
Nice. What next do you want to show?
Next we probably want to show you. This is still you got our.
It's durable.
Yeah. Well, this is our automotive grade PCIe 2.5 inch U.2. So again, like we said, we have BGA underfill, we have conformal coating. This is up to 8 terabytes, and this runs at about half or 1/3 of a typical data center SSD. So the whole drive runs at 7.5 watts. So it runs very cool. It's optimized for -40 to 85 wide range of temperature.
Let's say I buy the best 2024 affordable self-driving EV. Why does it need to have so much storage? What is an electric car, for example, doing with all this storage?
Actually, most production cars don't need that much storage. They probably only need maybe up to 512 gigabytes of storage. But these are actually right now used by the car makers to log a lot of autonomous data, ADAS data logging.
Because they cannot just upload all this. It's a lot of data. It's too much for upload.
Yes, it's too much for upload to the cloud, so they need a very high performance, high capacity local cache to store all that data that they can later take that and upload to the data center.
All right. So it's special development cars, maybe.
Yes.
It's not necessarily mass production.
Yes, for mass production, we actually have another line of products. They're called BGA SSDs. So they're BGA PCIe SSDs built for production level cars. So they're smaller in capacity, but also very high in performance.
Nice. And it could be like Formula One car that could be tested, and while they're testing it and optimizing it, they want to store 1,000 different sensor data on the car while they race around.
Here. Yes, it'll be stored on these drives.
Potentially.
Yes.
Right.
I'm selling Samsung, but what's the machine?
These are our automotive grade SATA drives, so they're a little bit slower than PCIe, but they also come with the same, shock and vibration, environmental protection, at a SATA 8 terabyte. So they're still very high performance, but not so high compared to PCIe, but they're also very low power. So they're about 1/3 of the power consumption of PCIe. Yeah. So for those applications that doesn't require very high data rates but very high capacity, maybe they want to store, large amounts of data over a long period of time, that would be an ideal solution.
Because Flash, 3D NAND, all this stuff sounds amazing. The question is, how long is it going to last? I have so many hard drives, I don't know if they still work. It's hard to. Can you give a number?
Yeah, so we believe that with the proper firmware, if you store at room temperature, these drives should last you at least, once you store it, once you put the data on there, these drives should last you at least 5 years. With the proper algorithms to make sure that to ensure that the retention hold up over time.
Do you think if somebody finds this in 100 years, there's a chance it still works?
That would be kind of iffy, actually. Yeah, unless you're running this in like a lower bit mode, like PSLC mode, then it's probably more likely. As long as you don't put too much data, too much. If you don't wear out the drive too much, like in terms of writing too much data to it, and if you put it in PSLC mode, I think it may be able to last that long.
I did that video once with some researchers. They were talking about 3D NAND, and it sounds so fascinating, but it sounds like potentially you could one day maybe get more storage than hard drives for cheaper, or is that not going to happen?
We're
Is it
seeing
going to
that
overtake
happening
at some point?
Well, we're seeing that happening for 1 terabyte. I mean, at 1 terabyte below, we're seeing the SSD cost is actually getting lower than HDD. So I think as we continue to scale down or scale up on capacity, maybe within 2-3 years it'll be 2 terabyte and keep going. So I do see that happening, and we do see there's going to be scaling limit on HDDs, in terms of how much capacity can actually carry.
Is there a chance that the capacity might exceed hard drive?
Oh, I think it's very possible.
Could you suddenly overtake and be like 80 terabytes or something?
So, by the end of this year, we'll have a 2.5 inch that's 32 terabyte. So
end of this year.
Yeah.
Wow.
So it's very
That's pretty much overtaking, kind of.
Huh?
It's kind of like overtaking.
Yes, but it gets kind of expensive. So not on the cost wise, but definitely on the capacity. I mean, on the form factor, because like most HDDs are 3.5 inch, right? So this is 2.5. So per volume density, the storage density of SSD is already way past HDD.
There's no chance you can make some 32 terabytes that are affordable? That'd be so cool.
Yeah, maybe 10 years from now.
I'll throw all my hard drives away.
Oh, well, actually, in my household, I don't have any hard drives left. So I recently upgraded my NAS with our 8 terabyte SATA, and it was a very enjoyable experience because now you can rebuild RAID at least 100 times faster than running a HDD.
But you need at least 2, no? You need to mirror everything.
So I bought 5. I got a discount because we build drives.
All right.
Yeah.
That must be really fast.
Yeah.
So what are you showing here?
So these are industrial SATA. I think they're minus 40 to 85. Kind of like the automotive, except without the coating and the BG interfill. So these are very small factors of SATA. The M SATAs, the 2280s.
Yeah. You actually do show rockets.
Yes, well, airplanes.
Because they vibrate a lot.
Yes. So our connectors, they have to be MIL 8110D certified. We also build custom storage where we actually build ethanol. Our drives are actually built with ethanol or Samtec connectors. That's shock and thermal, shock and vibration resistant.
Nice. It sounds awesome.
Yes.
This kind of technology, these cables. Sometimes I've seen, like in the video world, I've seen sometimes they have a HDMI with the screws. You kind of screw them so it doesn't fall out.
Yes.
But you have the similar kind of stuff for SATA connectors and everything.
Actually, we're building one that's not just for SATA and PCIe, but we're building one USB storage that has automotive grade USB, so it's protected against shock and vibration.
Nice. Cool.
Yeah.
What's next you want to show here?
Well, since you're using camera, we can talk about cinema SD cards, micro SD cards.
Because your market is all the professional video makers also?
Yes, we have a big market on cinema, so you can buy our products on Amazon, on the e-commerce platforms, and so we want to showcase our industrial grade CF Express and CFast cards. So they can go up to 2 terabyte for CF Express and 1 terabyte for CFast. So like I said, we are leading the edge. We are leading edge on CF Express, but we are also continue to support our trailing edge technology like CFast.
Now this is really high bitrate video supported on these.
Yes.
It says max sequential.
Oh, that's CFast.
Read. And
yeah, you want to look at CF Express.
This one?
Yes.
So
we can do 1,500 megabytes second or 1.5 gigabytes sustained with the proper cooling.
That's a lot of. That's a lot
of pictures.
A big raw 8K video.
Yes. So
8K 120. I don't know, something.
8K is probably 2 gigabytes, so it's getting close to 2. It's getting close to 8K.
So you're going to support it. When all these cameras come available soon, there's already some, but when more and more cameras become available, you'll have the storage for it.
Yes, so we actually support Canon R5, R3. We support the Nikon Z9. We're the fastest card for my Nikon Z9. We also support, the Panasonic GH6. And we also have a certified card with Red, one of the premier Hollywood cameras for filmmaking.
These Red guys, they do a lot of 8K stuff, no?
Oh yes. Well, right now they're not 8K yet, but the CF Express, the CF Express will be able to support 8K in the future.
I was kind of like on these forums with rumors when people chat about the next generation cameras. I wondered if they could do RAID recording, like not just copying but speeding up when you have two.
Yes.
When you have two cards, if it's 1,500 plus 1,500, and at the same time you might even have multiple copies.
So that would be a little challenging for the camera vendors because that's a lot of power consumption. But with the CF Express cards, what's different about CF Express versus microSD and SD is the controller is much more powerful. So they can do a lot more for the user in terms of data protection, in terms of data integrity. So with CF Express, we're pretty confident that you don't even need to do backups anymore. Just one card will be enough. And if something goes bad, we still have our data recovery service that can help users recover their data.
Because with my SD cards, I like to do dual recording.
Yes.
But that's the SD card is a different controller.
The controller
is
completely different. Yes. It's a much more cost-conscious controller compared to PCIe. So the capability is also limited, especially on error correction.
And you also have the small one, the Type A.
Yes, we also have the Type A card.
Yeah. Right. It's right here.
So for the Type A card, we took a different route compared to Sony. We actually did all of our own PCB design, and we did all of our own casing design. So that's where we're able to push the limits of CF Type A limit capacity pretty high there. So
what's your capacity there?
So right now we're offering up to 480 gigabyte on the Type A, but very soon we'll offer 1 terabyte.
Wow.
Yeah.
And is that going to be the best Type A? 1 terabyte?
We believe it will be a very good cost performance for the Type A market. Yeah. And it's also very low power.
But in the Sony, for example, the A7 S3, they have dual slots.
Yes.
So you backup record to those Type A.
So it's actually, for Sony cameras, there's actually limits on what you can do with the backup recording because on the SD card side, the most you can do is V90. So you cannot record very high resolution at V90 rates. So even if you want to back up on your SD card, there's certain resolution that will not be doable.
But if you have they have two slots for the Type A, I think.
If they have 2 slots, then they can do backup. But I'm not sure if they can support 2 slots at the same time.
All because right. It's a lot of power.
Well, it's a lot of power, and you need to design with two PCIe lanes, which I'm not sure if Sony supports that or not.
So Canon has been doing some 8K cameras like the R5, I think it's called, and all that.
Yes, and the R3, and they're gonna have an R1.
And you totally support those.
Yes,
you have great storage for them.
Yes.
And you have a lot of customers in the US and Europe or Asia or where?
Yeah, we have a lot of customers across these 3 big regions.
And you can go on the Amazon for these regions and they will be there.
Yes, so Amazon is our main outlet for and B&H. Amazon B&H are our main outlet for media card type of products, but then Mouser is more for our B2B products like
How about a camera store that wants to resell those? They just contact you and place a big order and...
Normally we have our distributor in the US. Our distributor in the US is OneSource Video. So that's where, we supply all of our cards to OneSource and they can distribute it for us in the US.
And here I see a rugged SSD.
Oh yes, this is a portable SSD that we developed for the cinema world.
And the creators, content creators, definitely need to get on board with these kind of rugged SSDs.
Yeah, so basically it's IP67 water and dust proof, so you can take this anywhere. Like, you know, anywhere where there's water, dust, humidity, salt, it's well protected for that kind of use environment. And we built a very high capacity drive storage for this USB. It's up to 8 terabyte. So imagine, you know, the amount of content you can put onto this drive. And because it's such a high capacity, we really designed this to be high performance. So it's about, we can sustain 2 gigabytes per second at, you know, 50 to 60 degrees Celsius. Room
2 gigabytes per second.
Yes.
What is the connection? Because I have one of these M1 Pro MacBooks, and they say they support 40 gigabit per second.
That's a Thunderbolt.
But I don't know if there's any external hard drives that support the 20 or something.
Yes, this supports 20.
20 for sure.
20 for
on
sure.
Those MacBooks.
On the new MacBooks, probably. Yeah.
So you, because they were talking about USB 3.2 Gen 2 or something.
By 2, yes. This is USB 3.2 Gen 2 by 2.
It is supporting that.
Yes.
So you totally got the 20. Because some of these SanDisk products, SanDisk was saying is 20, but actually it's only supported at 10 gigabits.
Yeah. So
on the MacBooks.
So what's so different about this storage is we don't use SLC cache to show like a bursty performance. Like, you know, like you can do 2 gigabyte for 2 seconds, and the rest is one gigabyte or even less. We try to make sure that you can record across the whole drive at a sustained 2 gigabyte per second data rate. So what that means is really you can offload or you can load the whole drive in 1 hour. 8 terabytes of data in 1 hour.
That's amazing.
You know, I know a lot of cinematographers complain to us about how they're using HDD. It takes them forever to transfer media. With this, you get at least 20x acceleration on data offload.
And so that means you have the controller in there that supports that latest USB gen and stuff.
Yes. So we optimize the whole performance, power, and thermal to be used for, you know, USB Type-C.
What's amazing with that solution is that people should get the MacBook with not so much internal storage, just get one of those.
Oh yes.
And then they can do all their video editing, 4K 60 off the external, fully smooth.
Yes.
Same experience like if it's internal.
Maybe even faster.
Maybe even faster.
We're actually pretty confident that it should be faster because NAND Flash's performance is limited by capacity. So at 8 terabyte, you have no performance limit. It can saturate the USB 3.2 Gen 2 by 2.
Because the M1, M2, M2 chips that Apple is selling, pretty amazing. But it's nice for them to keep the storage external, so you dissipate the heat, keep it outside your MacBook, and save some money and put the money in external storage. You probably get more per dollar.
Yeah, not only that, they charge quite a bit for an additional 256 and 512 gigabyte, right?
Extreme.
So think about it. For the same money, you can get 8 terabytes, and it runs faster.
I always choose the lowest one.
Yeah.
And I want to go for the external.
Exactly.
And get much more storage per dollar.
So people use this for direct video editing, you know, like high-def video editing.
And there in the front, you have a demonstration. You're showing at your booth.
Oh yes.
This is.
So pretty much this is what we're doing with conformal coating. So the drive is conformal coated, and it'll operate as if it's not in water.
Is it something like what they were talking about, P2i, or these kind of guys that are putting it in some kind of oven, and then it gets coated by something?
Yes. So we actually have an automated manufacturing process that coats the PCB with a humus seal, and then it's cured in an oven for about 2 hours. And once that's done, then a protective coating forms on the PCB that protects against water.
But that's not all your storage, right? Some of them.
Some of them. It's an optional manufacturing process.
And then that's the ultimate liquid cooling.
Well, we don't really need the liquid cooling because the drives are actually fairly low power.
Yeah. No need to liquid cool.
Yeah.
But you're showing that it works, and you're showing that it's just keeps working even though it's in the water.
Yes, yes.
Cool. So a busy embedded world.
Yes.
Lots of potential embedded industry people talking to you about.
We're excited to be
storage.
back here. Last year the crowd wasn't as much as here this year, so we're looking forward to meeting more customers and sharing with them more of our products and services. Much, Nicholas.
So do you want to walk?
I like to get as many cool things in the background as possible, and as much as you can, just start going to illustrate stuff, and even grab some things and show it on the camera and everything. Up to you, if it's relevant. Okay.
Okay.
Okay. 1 second.
Hi, my name is Thomas Lorenzo. I work at ARM in the IoT line of business, and welcome to the ARM booth.
So here, the embedded world is pretty much the ARM world, right? Everybody's doing new ARM projects here. There's a lot of new announcements also.
Yes, super excited about the partner announcement this year. We've seen several partner announcements in the MCU world, such as the ST microcontrollers, which were announced. Also, Renesas is showing off the Cortex-M85, which is one of the highest performance M-class CPU we have to offer, so really pushing the boundaries of performance for machine learning, for signal processing, but also for regular scalar workloads.
There's a lot of demand from some parts of the embedded world to get more performance on all these microcontrollers.
Yeah, we're definitely seeing several trends, right, driving more compute capabilities at the edge, right? There is certainly machine learning, as I said. You find demos around voice-activated door locks, for example, which is quite interesting. You find demos around connected motor control, integrating machine learning into that for predictive maintenance. But also at the higher end of the spectrum, definitely more applications around machine vision, integrated also machine learning capabilities into that, so basically running a multi-core Cortex-A based system.
I saw some booths that were talking about Cortex-M and GPUs and stuff like that.
Yeah, absolutely. No, we definitely see vision and graphics becoming more interesting also in the MCU world, so doing things like smart displays in appliances, for example. So that's certainly where GPUs are now extending into the microcontroller world as well. Very excited about that.
And Cortex-M with AI.
Cortex-M with AI, absolutely as well, yes. So there is, as I mentioned, the Cortex-M85 from Renesas that's integrating now the Helium technology. So Helium is a vector processing capabilities on Cortex-M for signal processing and machine learning. So that's really pushing the capabilities of those microcontrollers. But also we're seeing partners, as we have over there, if we want to walk over there, is that some of our partners like Himax, they're integrating the Cortex-M55, which was the previous recently announced, and integrating our Ethos U55, which is a neural network processing unit. So you can see here the demo with the camera.
So what is the ARM processor?
It's the Cortex-M55 with the Ethos U combined with the Ethos U55, so really targeting machine learning in tiny applications at the endpoint, essentially.
And it all goes on one SoC?
It all goes on one SoC, really targeting battery or power-efficient solutions with usually battery-operated applications.
And they can do a lot of stuff right there.
They can do
all the stuff that usually is in a Cortex-A with all kinds of stuff. Now it's also in embedded.
Everything is running at the edge, in the endpoints. You can do all the inferencing at the endpoints for enabling applications where you don't even need any cloud connectivity.
All right. That's cool.
Yeah.
What else? What next you want to show?
Yeah, we can show over there if we go back to. So we have something we started last year. Is initiated is a project called ARM Virtual Hardware, and the idea here is really that you can start your software development before the hardware, the physical hardware, is actually available. So virtual hardware essentially is a virtual representation of a physical board. So if you think about in the past, right, you always had software development and hardware development were kind of sequential. So software development to some extent started after the hardware was available. The concept of a virtual hardware now really enables developers to start with their software development before the physical board or the hardware is actually available. So very excited about that because it enables faster time to market. And
is it simulation, emulation?
Yes, it's basically using some ARM technology we've had in the house for decades, which we're using actually for our modeling of SoCs. And then we have another solution where we partner with another company where we're providing basically modeling of full physical boards. So you could actually start develop on a virtual Raspberry Pi, for example.
Is it FPGA stuff, or it could be different? What it needs to run on?
It basically runs in the cloud. So you have you log in into AWS essentially, it's running on AWS instances in the cloud. So there's no physical board, there's nothing involved in that.
Cool.
Yeah. So if you go around, there's something else I wanted to show you is really about, as we talk about the edge, right? There are so many different use cases. It's
right here.
So many different use cases. It really is sometimes mind-blowing, right? You have all the way from Cortex-M, smallest microcontrollers, all the way up to, as I mentioned before, right, really machine learning or the machine vision running on Cortex-A-based devices. And what we see, especially in the A-class world, is that often you have platform or software development for each individual platform, which often is, as we look at that, we see that that there are things which our partners or the developers have to do for each individual platform, but there's opportunity really for reuse, right? Because we don't have to reinvent the wheel often. So what we're working here on this specific program called System Ready is really about how can we, or what can we standardize in the software development flow or in the software stack, so that our partners or the ecosystem can focus their efforts on differentiation. So what we're showing here is there are 5 different boards, so Raspberry Pi and Pine 4, Arduino, AD-Link and Contron. And what you can do here is you can use various different operating systems, which basically can boot on any of those devices. So System Ready essentially really works around the interoperability between operating systems at the layer between firmware and the operating system. So standardizing that layer essentially, so that any operating system can land on any System Ready certified hardware.
Nice. So interoperability.
Yes, exactly. So what that means, right, is really you can run any operating system on any board. So you can, the demo here shows that you could use a USB stick with, for example, Fedora or SUSE. You plug it into that board, it basically boots the system. You can use the same USB stick to boot up your Raspberry Pi, for example. So this is really where we see a lot of value in this program, because booting the system is basically much easier. You don't need to spend time to develop your code and to just boot essentially your Linux image on
it's one of the arguments of the ARM, right? Is to be interoperable, and once you have software on one, you can do the other. But now this is the next level.
Absolutely.
To get it even more. Put a USB stick, a little bit like what some people do in the x86, and they just have a Linux and they somehow boot it.
Yeah, absolutely. I think it's about the developer experience, right? And this is what we really want to enable with standards. That's why standards are so important for us, because it enables the software reuse. There are aspects of the software flow or the software stack which are often non-differentiating. So that's where we developed and collaborated with the ecosystem and developed together the System Ready standard to really ensure that any operating system can land on any ARM System Ready certified platform.
All right, cool. So that's a busy show and lots of demos. There's lots of other stuff, but we cannot cover everything, right?
Yeah, no, it's super exciting to be here. It's very busy. It's great to see the industry being together again, and it's great to see so much stuff on ARM.
Hi. So what's the latest here at the Embedded World 2023?
Hi there. Well, today we're showing our many new things. This is one of them. This one is called our Jasper CommExpress carrier board. What you see here is the top side of the board, which has all the I/O and all the expandable sockets, things like that. And on the back side of the board is the CommExpress socket. So you can see here the standard CommExpress connectors. This supports Type 6 CommExpress, both compact and basic form factor. And this metal plate around it is a mounting plate. And what happens is the CommExpress and its own heat spreader fit in the middle of it. So this thing is a general purpose platform, and you can work with any CommExpress Type 6 module. And then the idea of this is that it's meant to be put inside of a rugged system. So it forms a scalable platform for a rugged computer system. And what we have here is that the whole board is designed for rugged applications. All the connectors are rugged and latching. The board PCB is thicker. If you can see that it's a thicker PCB, it's a 0.093 or 2.3 millimeter thick PCB. And then we have latching connectors for everything. We have M.2 and PCIe mini card for I/O expansion. We also have PC104 Express socket here for I/O expansion as well. It has PCIe by 1 and by 16. So if you have a Xeon COM or later generation CommExpress, then you get the PCI Express by 16 lanes. And so this can allow access to those lanes for high performance rugged I/O like video capture or graphics or other 10 gig Ethernet and so on.
When you talk about the CommExpress Type 6, basic and compact,
right.
There's a lot of stuff that use that.
Yeah, it's pretty much the sweet spot of CommExpress, the two sizes. The compact is more popular because it's smaller, 95 by 95 millimeter. The larger size, basic size, usually will have higher Xeon processors or more memory, more memory capacity because it has more room for memory sockets and so on. So, but this worked with both of them. So it was designed to be general purpose so that it can fit either the mainstream or the high-end CommExpress.
And so it's like a COM port, but much more speed than the old-style COM port.
Well, it's whatever the CommExpress can offer. So, CommExpress comes in many different levels, right? The whole value of CommExpress was two values. The first one is that you can design one carrier board like this, and then you can plug in any CommExpress module so that you get scalable performance. So if the customer wants to improve the performance, you can pick a different COM that has a higher performance and put it on there. Or if they want lower performance or lower cost, you can pick a different one. So it suits the application precisely. The other thing is that because they're all interchangeable, if one CommExpress module goes end of life or becomes obsolete or hard to buy, you can switch to a different module. And so it gives you the ability to maintain a product lifecycle much longer than normal. This is really critical for anybody in long life applications such as military or railway or medical. Those are the typical applications where they need very long lifetime. And so what CommExpress or any COM-based solution does is it gives you access to a solid platform where the platform itself remains the same, but the performance can increase or decrease with time, and it can last longer. So the product can stay alive longer.
This is Intel?
This is all Intel x86 technology.
Where does Intel go?
Where does Intel go?
And how do you design around it? Thermally, everything is smooth?
So it's so the idea that we do is it's all conduction cooling. So the module goes on here. Unfortunately, I don't have one to show you. Oh, here's the module, but I'll show you this. This is the module. It doesn't have the heat spreader. So here you can see the CommExpress. So this is the actual CommExpress module. It's mounted on top of, or underneath rather, in this case, the carrier board. The same Jasper carrier board that you see here is actually here. Now it's upside down. And this plastic cover normally would be a metal heatsink cover so that it's for heat dissipation. So all the heat is going through the heat spreader and into this case upper surface with heatsink fins on it as normal. That's how the heat dissipation works.
So then you can just throttle it at max speed, just run
depending on the thermal characteristics
you want.
Depending on the thermal characteristics of the enclosure, you can max out performance, right? So it all depends on what the enclosure can handle.
And what are the applications, like 2 or 3? What does that look for?
Well, so this is a rugged system that's really targeting military applications because of the size and ruggedness. This is a typical box PC you would see, or mission computer you would see in a military vehicle, where it's got the rugged connectors that are all sealed and super rugged. You can step on them and kick them and so on. They've been around for decades. They're very solid, very popular. And so this design, this is intended to be a rugged computer system that offers scalable performance. So that it has CommExpress inside of it so that you can pick the performance level you need, pick whatever processor the customer wants, and also you can maintain a long life cycle. Because again, in military programs, they want the product to go for a very long time. They don't want to risk that the product has to be redesigned if the CPU goes end of life. So with the CommExpress-based solution, then the product can last longer. And that's the whole purpose of this platform.
And sometimes when something is military spec, it's not necessarily military. It could be all kinds.
Sure, this could also be used in any rugged application, like for example, mining. So we have here an example of mining, right? These vehicles also require computers, and they also require extreme ruggedness, high shock and vibration tolerance. So mining is another very common industry where products like this are used.
And how about these oil rigs out in the sea?
Those usually have a lot of demand for wide temperature and sealing for rain and water and that kind of thing. Maybe not as much shock and vibration. Although we have a new program now for an oil rig where they're talking about high shock and vibration because they are drilling and the pipes are very heavy and sometimes they drop the pipes on the platform, and they said when the pipe drops it's super high shock. So there's another application where the shock and vibration protection is needed.
Are you in rockets?
We have a few projects in satellites, yes. And we are actually in some satellite networks that are going up. We're using some of our products in them, but it's not this. It's a different product family.
It needs to work up there.
It needs to work.
It needs to work for the
There's
whole.
a whole different set of issues.
Launch.
Whole different set. The launch for sure is a high shock and vibration environment. Once you're up in space, the issues become temperature extremes as well as radiation tolerance. Those are the other issues, and also zero pressure. So there are other issues with components when you're talking about high pressure or low pressure environments.
And this is cutting edge in terms of what people need and what people want in the industry.
What's special about Jasper, in our opinion, is that it has a lot of I/O in a single board and a lot of expandability. So that if you just use this as a platform for your application, then you're pretty much guaranteed not to run out of space and not to run out of time. You can add whatever I/O you want to expand it in many different form factors, either minicard, M.2, or PCIe 104. As well as you can have your choice of CommExpress modules from dozens of manufacturers, and so you have long lifetime. As well, and you can pick whatever processor you want. There's going to be a COM available for it. So that's what this gives you. So we're pushing it as a platform for high performance applications that need a lot of I/O.
And this metallic plate is required, or?
This is the mounting plate that is used to mount it into the enclosure. It's not required. You don't have to have it. It's just a convenient mounting plate because the actual cooling is from the CommExpress heat spreader, which is inside the middle here. So this is only a structural member, and it could be done your own way. We just offer this for convenience. But the real thermal dissipation is coming from the CommExpress heat spreader, which is in the middle here.
And on the piece of paper right here, you talk about some of the other specs.
These are just the general I/O features that it has, right? So you can get a quick view there. Another nice thing about this product is that we come from the analog I/O world. So Diamond actually started making analog I/O data acquisition boards. And so to this day, we still sell a lot of analog I/O, and we embed the analog onto the SBC. So we have a whole line of SBCs where we have integrated analog I/O on them, so it saves the customer an extra board. Instead of having to buy an analog I/O card and plug it on the board, it's all built into the main board. And so this board has it also. But this board has the same circuit right here. This particular model is the low-cost model, so it doesn't have it. But it's available with a complete data acquisition system here, FPGA-based data acquisition with analog and digital, and it has auto-calibration to maintain high accuracy over wide temperature range.
Do you want to show the whole range of that you
I can show the other products that are similar, sure. So here we have another product. Now this product is called Saturn. This is more of a mainstream, typical single-board computer. Everything's on one board here. It's got PCIe 104 expandability. It's got M.2 and minicard expansion as well. And the CPUs on the back side, you can't see it because it's underneath the heat spreader. But on the other side of these thermal pads is the processor. And so this is a single board computer in a more traditional form factor, again with a heat spreader mounting plate for efficient cooling, and then expansion and I/O are on the top side. So then here again, we have the same analog I/O circuit as you saw on the other board. And again, this board comes both with and without. Not everybody needs it, so we make it in two versions. This is the model without the analog I/O.
And the people who want the analog I/O, they want it for, what's the purpose?
Real world, right? So it's easy to have a thing serial port Ethernet. Everybody has that, but a lot of times you have things like you have to monitor pressure, or you're monitoring water flow, or you're measuring light intensity, or you're measuring gases in a system because you have some kind of like IC manufacturing, you need to have measure the gases, the gas flow and the gas purity, that kind of thing. So our boards are very common. Or air quality is a big application for us. People are measuring air quality.
All right.
Yeah, so all these boards pretty much have analog I/O on them. Even this little tiny one called Zeta here, this one I'll bring closer so you can get a better view. Zeta also has analog I/O right over in this area. That's a pretty nice lens you have there.
Oh, nice.
And over here, you can see again it's COM Express. It's a two-layer, two-board solution where you have the carrier board with the I/O and the expansion, and you have the COM which has the CPU on it. So that's how we're able to put analog I/O on a board this small. This is called our Zeta board.
So are you famous for supporting the analog I/O?
I think we're pretty well known. If you ask people about Diamond, they would say, oh, Diamond's the PC104 I/O company. We're trying to divorce ourselves from being seen as a PC104 company because we do so much more now. We actually have 4 complete product lines, and analog I/O is part of the I/O product, which is, again, part of the single-board computer product line, which is here. Then we have a very successful line of Ethernet switches, which I think you've talked about in the past. So here we have single-board switches, expandable switches with daughter boards with more ports on them. Here we have a switch module, which is very much like a COM, but the switch module is basically a switch instead of a computer, and the same thing where you plug it onto a carrier board, and the carrier board completes the circuit and has the rest of the I/O. So what these are carrier boards that break out the I/O on the switch module. So this is the actual switch with the processor and the firmware and the power supply and everything. It's built-in application software. And this one is the I/O, so it's got the magnetics and the connectors, the SFP, and so on. So it just breaks it out to a full solution. Typically what customers will do is they will buy the switch from us, which is the hard part, because it's all the high engineering and software development, and they'll make their own carrier board. This is the easy part. So it divides the solution into hard and easy, so they can get to market much faster, and they can make a custom solution without doing all the work.
When you say analog I/O and you have a history in doing that,
You're right.
when did you start doing that?
Diamond was started in 1989. So I've been with the company since the beginning because I'm the founder, and so we've been making analog I/O, digital I/O, Ethernet serial boards for 33 years now.
What did you do in '89?
Sorry?
What was the product in '89?
We were making slot boards, actually, PC slot boards, ISA boards. And then we moved to PC104. When it first came out, PC104 was just the ISA bus. And so we took all of our existing circuits and moved them into the PC104 form factor. And then that became very popular. So, and then from there we went to make x86 single-board computers, then Ethernet switches, and so on.
And it's fun to see all the markets that adopt your technology.
You know, we have the craziest applications I would never even imagine. People do all kinds of crazy things. One interesting application was a company making potato chip packaging. They had to measure the thickness of the material being made, the aluminized plastic film. They had to measure it at high speed when it's being manufactured. And so they would zigzag a radioactive sensor across the material, and the amount of scattering dictates the thickness of the material. And they would use our analog I/O board to measure the scattering. So that was an interesting application. That was a very big one for a long time. So we're helping to make potato chip bags.
I hope the chips aren't radioactive.
Just the packaging. Just the packaging. Then it goes onto a roll and goes off to wherever. You know. But you get all kinds of, when you make I/O, you see all crazy applications around the world. And things you never even knew about existed, but it's just amazing. It's a little slice of life. We have something like 500 active customers, which is pretty amazing for a company our size. We have 500 customers, and they all do different things. You know, we have UAVs, we have submarines, we have military vehicles, we have potato chip manufacturing, we have medical. One of our big customers also makes a lung simulator. So all the respiratory equipment in America has to be calibrated so that you don't blow out someone's lungs. So it has to be calibrated for different body types, and baby, adult, woman, man, that kind of thing, for different conditions. And so they have a lung simulator that they use to calibrate their equipment, and that uses our computer board with integrated analog I/O as well. So it's a really interesting application for analog. So
and here at the Embedded World, lots of meetings with all these
non-stop meetings. Well, we have a lot of sales partners that come to visit us here. So typically we have sales meetings going on all day. This is a small, lucky break in our meeting schedule. So I think the guy's off to lunch right now. We'll be back and having more meetings soon. So yeah, we have meetings here, and we have some customers coming to see our newest products.
Cool. And we're going to do a second video right now.
Let's do a
about
second
different
one.
topic.
Well, let me show you one more thing, though. We mentioned this product here. This is called Geode, right? Our Geode is our rugged system. What I didn't mention is I mentioned the fact that it uses the CommExpress module for performance, scalability, and long life. But what's also interesting, if you look inside here, if you can get in there, if you can get way inside there, you can see that there's a board-to-board connection. So the I/O board doesn't have cables. All the I/O connectors are mounted on a circuit board, and that plugs directly onto the main board, so it eliminates the cables in the box. And what that does is, number one, it makes the box more compact because you don't need the room for the cabling. And number two, it allows you to get higher shock and vibration because you don't worry about the cables. And even number three, it makes it easier to manufacture because it's quicker and easier and more reliable to build a circuit board than to build cables. That when we build rugged systems like this, the number one sticking point is always the cable manufacturing. To get the parts, to build it, to get them to build right, you know, have them come out right, and not make mistakes. It's much easier to build a circuit board, so better.
You've solved cables.
We try to solve the problem, right? And not only that, but also we have built-in expansion connectors. So all of this is for the standard x86 board. All the I/O on this board comes out these three connectors. And if you want to add more I/O, remember that on here we have 2 mini cards, PC104 socket. So if you want to add even more I/O, all of these could get cabled out to these connectors on the back side of the panel board. So the case and the connector design remains exactly the same. So there's no custom design required. So we eliminate custom design, which eliminates NRE charges, reduces time to market, and provides a more rugged, compact product. So it basically solves every single problem that you could think of.
And you provide this amazing solution, and maybe there's a big team that then goes on customizing some software or whatever they need.
Yeah, so
for
the
the
customer,
specific application, right?
The customer will basically buy a platform like this. They will write their own application, and they may add additional I/O, like a radio or some other sensor they have, or some like military bus interface, or whatever it's going to be, right? Maybe they have some other kind of I/O they need, and they can put that inside the box, and they don't have to do anything with customization. It's all ready to go. Just plug the board in and cable it out, and you're done.
Nice.
So it's great for quick turn, easy custom, customized solutions with no NRE charge.
Cool. And then we're going to do another video.
Okay,
right?
okay, sure.
Okay, let's go to the next video.
Oh, next video right now? Okay.
Okay. Right, so let's start at what you can see up here.
Did that come out okay?
Yeah.
Okay,
that's great.
not too many ums or anything?
No, it's perfect.
All right, all right.
I was thinking we could do one long, but I think it's good to start with the second one.
Two is
then
people
a
can watch
separate-
different things. Yeah,
separate
yeah.
publishing
People
for
can,
this
right,
one.
exactly, right.
And if
right.
there's anything else that's more related over there, maybe,
these
then we
are
go
here.
to this. We go
okay,
there.
okay, thank you.
One
okay.
second.
Okay.
And then it's always looks good if you can.
Yeah.
In the video.
Yeah.
Okay, let me start it right there. So I'll do like this, and then you can say hi.
Okay. Hi, I'm Jonathan Miller at Diamond Systems, and we're here at Embedded World, and today I'm showing you our newest NVIDIA Jetson carrier board. This is called Osborne, and if you know Diamond's products, you know that all of our NVIDIA Jetson carriers are named after rock and roll stars or rock and roll characters. So here we have Osborne. So there's a couple people whose last name was Osborne, maybe you can think of them. Anyway, Osborne is our newest product, and this is focusing on the AGX Orin, which is NVIDIA's highest performance carrier, GPU module. The Orin module mounts right here on this socket, in this area on the board, and then we have it's covered up on this side. Let me see if I can pull this off to show you. There we go. Okay, on the back side we have expandability, so we have 2 mini cards, we have M.2 socket here for modem, and we have a camera adapter board here. In addition, we have here a PCIe by 8 slot connector. So if you have a high performance graphics card, you can, or camera interface board, you can plug it in here. So it's got a lot of expandability as well as a lot of I/O on the board already. Now the interesting thing about Osborne is not just that it has the AGX Orin support, but also it has a concentrator connector over here. So all the I/O on Osborne comes out on a single I/O connector. What this allows us to do is make us a group of interchangeable I/O adapter boards. So just like you might plug an I/O board on top of a board, here you plug an I/O adapter board on the connector, so you bring out the I/O in exactly the way you want it. So in this particular case, we have these commercial style connectors, RS-232, DB9, RJ45, USB, HDMI, and so on, right? And these connectors, this is for CAN right here, RJ11 is for CAN, and then power. So this is the commercial style connector board that can be used to go inside of a typical box PC kind of enclosure. But if you wanted to use Osborne or use the AGX Orin in a rugged application, then we have a second connector board that looks like this right here with the military style connectors, right? And so here we have the exact same board-to-board connector, but now we have different connectors on it which are designed more for a rugged military application. So the same carrier board can fit in any different application. And of course the customer can design their own carrier board as well, I/O board as well. So that if you want to do something different or a different kind of connector or even different military connectors, whatever, then we give you the design files and the specs and everything, and you can make your own adapter board to adapt Osborne to your application. So it's kind
Could
of
you describe a little bit, what do you call this connector here?
Oh, so this is basically just a module connector. I don't have an example of the Orin module here, but the Orin module is like a big metal cube kind of thing, and it plugs directly onto here.
And it has all the input, output, power, and everything?
Right, everything you need to drive the Orin is on this connector. 699 pins connector.
That's a lot of pins, right?
That's a lot of pins.
Connector.
That's a lot of pins, that's a lot of money. And that's everything, that's the whole interface. Then it mounts on these four threaded spacers here. Standoffs.
And then you were talking about this right here.
So this is just a standard desktop slot connector that you plug in a typical slot board in. It has PCIe by 8 on it. The Orin module has PCIe by 8 available, so we bring it onto that connector. So some customers want to use those desktop style adapter boards for whatever reason, graphics or Ethernet or something like that. So we give them the ability to do it with this connector here.
And there's 10 gig.
10 gig Ethernet is available on this board, yes. 10 gig, there's one 10 gig port available on the Orin. We bring it out here. So it's actually on this connector. I think the bottom one is the 10 gig Ethernet. Using a 10 gig PHY right here. This little part.
So this is high performance potential?
Super high performance. The idea is high speed video in, high performance GPU for analysis and inference, whatever you just want to do with the imaging coming in, and then 10 gig high speed Ethernet out, so you can get the data out really fast to the network. So it's a real high speed edge processor, and the whole chain is high speed.
You have many years working with NVIDIA.
We've been working with them for, I guess, 4 years now. This is our fourth embedded world with, the first time was 2020. Just before the pandemic, we had our first NVIDIA products. So it's about 4 years now.
And you have a bunch more?
Yeah, this is our latest one, but we actually we have one more in development coming out, but we're showing it here in the show. This one is called Jackson. Okay, so Jackson is for the other Orin products. Orin is actually a family of the latest Jetson modules. So AGX Orin is the high performance one that we just looked at. This one is for the Orin Nano and Orin NX. Those are the lower cost, lower priced. They call it entry level sometimes. And they're like a DIMM style, so they plug into this socket here, very low cost socket. So the module will plug into here, and then on top of it you have your cooling solution, and then the I/O comes out here. So this is more for the lower end applications. Still very high performance because the Orin is something like 5 to 10 times the performance of the previous generation. So you get incredible value, incredible performance at a very low price with the new Orin Nano NX.
What's the main CPU?
It's all NVIDIA GPU. The NVIDIA GPU is actually a
with an ARM also.
Yes, they have what they call it. I can't think of the word right now. Heterogeneous design. So they have an ARM complex, which is either quad core or hex core or 8 core or AGX Orin CPU complex to run basic Linux OS, basic applications, user interface, things like that. And then they have a secondary GPU, which is where all the fun is, which is for all the video and analytics and inference, AI, robotics, and so on. It's all being done inside the GPU complex on the module. So it's a kind of a dual processor.
the kind of thing they can do is they can bond a bunch of networks together. They can encode H.265, do all these advanced things people want to do.
Yeah, the most common thing I think is really video analytics. So take a picture and analyze what's in that frame. Do you recognize the person? Can you detect the motion of the person and what they're trying to do? Things like that. We have one application, for example, where they use the Jetson to analyze the video frame to watch people going into a building. So they can tell if it's one person or two people, or if you're trying to pull equipment in that's unauthorized, this kind of thing. So they use the AI in real time to detect whether the action at the door is authorized. And that's an interesting application of entrance control. So
Nice.
very, very interesting.
And there's other boards around here you want to talk about?
So this is the previous generation. This is called Floyd. This is the same, very similar, but the previous generation of our carrier board. Here you can see the module is actually right here. This is the Jetson module installed on the board, and this is the cooling solution on top of it. It's a heatsink with a fan on it. So it's very similar. There's a larger board with a little bit more I/O on it. This is called Floyd.
Right.
This
A
uses
lot of people have been using it.
Floyd is pretty popular. Floyd's being used in electric vehicle charging and pill dispensing and all kinds of applications.
Right.
Right. So that's it. And this
All right.
box. So these smaller systems are designed for this kind of enclosure. So that's why they have those connectors on them. So we put them inside a box. So you buy a complete solution. You can buy the box, make your own enclosure, or you can buy a complete box system from us, ready to go. So the module's in there, the Linux OS is installed, everything's ready to go, just powered up.
What's the minimum order quantities to work with you? Just one.
One, sure.
Just get
If you want to
started.
customize, different story. But we sell a 1 to $9.99 all the time.
All right. Cool. So, thanks a lot for the show.
Okay,
And,
thank you.
Always busy in the embedded world.
No matter what I think of, someone else thought of it already. A lot of innovation here. It's really drinking from a fire hose to come here and see what's happening. It's so much fun. Very educational.
introduce yourself.
This is Dimitris Anastasiou on behalf of Irida Labs. I'm leading the product growth team. Irida Labs is an embedded vision AI software provider, and we have developed our solution, which is Perceive AI, a software and services platform that can help you develop and deploy at scale vision AI solutions that are targeting the edge. So I'd like to discuss a little bit about the platform.
Is the website?
Actually, it's the platform itself. So this means that you need to have a very good understanding of all the steps involved when you want to create a new vision AI solution. So in this case, for example, when you want to develop a traffic flow monitoring sensor, you can just directly, first of all, create, 3D equivalent. Can we do this again, because it will take some time to load and we will waste time. Sorry.
Let me start again.
Yep.
Right here. It was live streaming, but it's okay. I'll record. I'm recording in 4K. Publish later.
I didn't know it will be. Is it live streamed?
Yeah, no problem.
It's also live, but let's start again.
Sorry, I didn't know about that.
No problem. Hi.
So it's very good to know that we're live. Okay, so this is Dimitris Anastasiou, hello, from Irida Labs. I'm leading the product growth team. We're doing embedded vision AI software, and we have developed a platform to help enable the development and deployment of vision AI at scale. This platform is called Perceive.ai, and I'd like to show you more here. So in order to develop a good vision AI solution at the edge, you need to have a good understanding of all of the steps involved. First step being the vision twin part, where you have the modeling of exactly what goes on in a scene in 3D, so you can select the right module from the camera and lens and optics. So this example is the traffic flow monitoring sensor that we have created for the smart city context together with Renesas. More on that in a little while. The next step will be to annotate and actually choose the right classes for your data. So through our platform on the cloud, you can directly manage all of your data sets. As soon as you're done with that and you know what you're doing, the next step is to start creating models. So first of all, you can choose and create a new model here by choosing the name, the description, the task type. You can select your data sets to make sure that you use the right data sets to create a model, and then you choose the deployment platform. In this case, we have selected the Renesas MPU DRZ-V12. As soon as we have created a model, we can directly see how well it performs right on the cloud after it has been trained. You can select a different model, or you can deploy a different model on the edge device. That way you can easily understand if something is going well or not going well. And of course, the final step is to get metadata directly from the sensors. So you have deployed sensors on the field, but you don't need to see their images, you just need to get metadata. In this example, we have a traffic flow monitoring application, so we're counting cars per minute. I'd like to show you a little more on how that works. So here's the real-time live demo of exactly what goes on. We have developed this solution. Actually, it's this Vision AI sensor together with Renesas. It has a tiny ML engine, and what it does is in real time it counts the number of vehicles that are crossing a very specific lane. This is the sensor level dashboard. This is why we're seeing here also the imagery together with the metadata. And of course, as shown previously, this is directly sent to the cloud. This platform, actually this solution is meant to run at very low watt consumption, and it's meant to be used in the smart city context, and it runs our tiny ML engine inside Perceive AI compliant. It interfaces with MQTT, so it can be directly integrated into a third-party platform, or maybe digest the metadata directly to another software provider's infrastructure. That's pretty much the summary.
Nice. And what's there on the wall? What are you talking about here?
Here we're actually discussing about different use cases that we have deployed over the years. So some of them, okay, now we have hit the part where it's just discusses about the platform, but the idea is that you have a lot of different markets where Vision AI can be relevant. So this example that we showed previously, it had to do with smart cities, but at the same time we're also, let's say, market agnostic. We have developed a lot of solutions for industrial players, for example, in the Industry 4 context, for warehouse monitoring, for inventory management, for truck monitoring, or also understanding what goes on in retail, in terms of product recognition, self-interaction, inside specific stores, perhaps some consumer analytics. So all of these are enabled through our Perceive AI platform, and this is the, let's say, the thing that glues everything together, from conception all the way to deployment down to the edge.
Cool. All right. Are you like a new company, or you've been working a long time on this stuff?
We have been working for quite some time, so we have been in the embedded vision field for, I would say, more than 10 years now. So we have a very good expertise of what's going on in embedded. This is why we're able to deliver solutions through our platform in a very timely manner. That said, we have been working in AI more than 5 or 6 years now, and the latest offering is, of course, our platform, which enables also other developers, aside from our company, or together with us with engineering services, to provide very good products.
And what's the collaboration with Renesas?
We're working tightly together to create the Vision AI sensor. So we're working for bringing this new product to the market, and actually through the business cases that we're working together to be able to scale in thousands this specific solution.
Because some of these newest ARM processors get even the Cortex-M stuff and the microcontrollers are getting extra performance to do all this kind of stuff. And
actually,
you use it?
Yes, some of that can be offloaded there. It can be done in in many applications. Sometimes you need an accelerator like the RZV2L, but indeed some of the applications can be offloaded to ARM, Cortex architectures. It's depending on the use case, and if you have the right expertise, and we're happy that we do, you can go very, very low and do very nice stuff with Vision.
Where are you based?
In Greece. We're 30 people strong, growing quite fast in the past few years. So.
In where?
Sorry?
Where in Greece?
In Greece. So the headquarters are due westwards from the capital, which is Athens. The city is called Patras. It's right next to the university, but we also have our offices in Athens.
So some students are coming directly from university and working in your company?
Yeah, we have had quite a few young talent joining us. Now we're 30 strong, so it's 30 people, most of them engineers. But yeah, we have also our senior people working for quite some time on this field.
Now a lot of people are talking about AI,
yes,
machine learning, vision, computer vision, and you are at the forefront of this?
We consider ourselves a leader. We have been in that for quite some years. And we care about bringing good quality products to the market. So we have deployed mass market in China. We have very good collaborations in products that plan to scale in the many thousands. And there is this buzzword, but there is a huge gap. You have what we call the CV tech debt. This means that it's very easy to deploy an open source solution, actually to develop an open source solution by using some of the models that are already available, but productizing, an actual, creating a product that does solve something, that's an entirely different discussion. You need to understand how to deploy in production, and for that you need to have an understanding like the one presented previously. You need to understand end-to-end what's going on. You cannot just assume that you have the best images and assume that these images automatically, reach you. In most of the cases, you have to deal with diverse scenarios, with different environments, being able to adapt, having the infrastructure to get the right data, and at the same time adapt to the environment, and also meet the bill of materials and the performance requirements. So there's a lot of discussion to be done there, because the buzzwords are nice, but we have to have products hit the market actually.
and please don't laugh.
No, I won't.
And no dancing and nothing else. So hello and thanks for being here. You're at our Renesas booth. You are now together with me. My name is Frank Urbe. I am leading the SST team. This is our system and solution team in EMEA. I'm together with my colleague Brad Rex. Brad is leading the SST team in America. And Brad, he will show us a huge new demonstration, a huge new tool we call QuickConnect Studio and QuickConnect IoT. And this is unique in the industry. And please be excited, please see what we are doing. And Brad, if you can give us some highlight information on QuickConnect Studio, would be really appreciated.
Thanks, Frank. So QuickConnect Studio and QuickConnect IoT are kind of the hardware and software brothers of each other. So QuickConnect IoT allows us to take our modules, plug them together in different formats and variations. That way you can make your application exactly what you want. And now what we're doing is we're making a software version to allow us to actually auto-create the software, and that's QuickConnect Studio, which we're showing. So we'll basically have a drag and drop type of solution where we can take our MCU board, we can take a connectivity board, and we can take
designing your system,
right, all from scratch. We're doing it graphically. So in this case, we would have an MCU that's reading in temperature and humidity data and sending it out BLE. We would then compile this.
Brad, just to interrupt you, is this now local on this machine or where is it?
Yeah, so this is all done cloud-based, so it's on a cloud instance. So it's all done online in a browser. So we can, when we're compiling here, we're going to use the cloud's compute power, so it's much faster. You don't have to have a very powerful laptop to do the compilation. It took 2 seconds to do the full compile. And then we're going to get the project file.
And now we are done?
We're all done. So what you see here is we get all the source code for the actual project. And then when we compile, we get the debug file. So what we'll do is we'll download the debug file so that we can actually do the programming. So that's there, and what we'll do is we'll switch over to our other tool. This will allow us, we'll erase it. We will select the file and we're going to program it. So we'll do the programming. So the device is programmed, and since this is BLE, we have a BLE app. So what we're going to see is, if I get a smartphone app here, select our device, and you'll see all the temperature and humidity data coming out. If we had a different sensor, like a flow sensor, you would see flow data. So the app and the data that's being sent out from QuickConnect Studio is automatically configured based on the actual devices that you're using.
What do we need? Do we really need a high sophisticated, high-end machine to run all locally, or what is requested from our customers?
Yeah, so you don't need much other than the hardware and a browser. That's pretty much all you need, and a way to flash the device locally to make QuickConnect Studio work. So really low barrier to entry. You're not downloading any tools, just a real simple browser and some hardware.
You can do it with a Chromebook.
You could.
And also you need something else maybe, but
you can actually, I did it before, you can actually load it on your smartphone and do all the configuration here. Obviously you need a way to download the file onto a PC, but you could use a smartphone with a browser to do all the actual development of the solution.
And that's can you talk a little bit, I see here two Renesas controllers. What is the next step?
Yeah. So right now, good point, Frank, we support 2 different MCUs, Bluetooth, Wi-Fi, and a couple different sensors. Our plan over the next few months and then for 2023, we're going to get all of our MCUs supported in here, all of our sensors. We're also looking at partners, so other technology that Renesas does not have, like gyro, accelerometers, things like that. We're going to get an ability to have our partners actually add in support here as well. So a lot of fun and exciting things coming in 2023.
This is a brand new way of doing things?
It's so first way in the industry to actually do it from this level. There are many online IDEs that already exist today, but that's really source code level. You have to do the programming and debug and development. This allows you to start one level above that at a solution level, then take that solution, make the code, and then from there you can then go on and do the next part of your actual development process.
WYSIWYG, something, what do you call it, drag and drop?
Yeah, WYSIWYG. Yeah, what you see is what you get. Yeah, same style. So basically, if we look at it, if it's exactly mirrored to what we have. So that's the whole point.
And then it comes with example codes, and you can modify and improve.
Yep, so the example code will intelligently look at which devices you have and auto-create that example. So for instance, if it's BLE, it expects that you would send it out to a BLE app, like on a mobile phone. If it's Wi-Fi, then you would send it out to a web browser, like an address page, so that you can take a look at it. So it intelligently knows which devices you have, and it will automatically reconfigure.
The question customers are very often having, what about the price? Do we charge anything to customers? What is our business model to work with customers?
So right now we're in a beta stage for the tool and development. So right now the tool is free of charge to use. It's renesas.com/QC Studio. Users just need to sign up for Renesas for a My Renesas account, and from there they're able to then use the tool free of charge. Please submit feedback. Let us know how you're using it. We want to get the features that users are most implementing added. So right now it's completely free to use, really. And then hardware, for hardware availability, Renesas provides samples, or you can get them through distribution. DigiKey, Mouser, and Avnet Future, all of our major distributors. Affordable, most of the boards less than $100. The little PMOD boards are probably $10 to $25 range.
All right. And, last question, we are now here at day 2 of Embedded World. You have met a lot of customers. Can you share high level, what is the feedback of customers? What is your impression of being here in Germany?
Yeah, everybody's very excited. First thing people ask is like, oh, it's very modern. It looks like Visual Studio Code. People are used to that. They like the new look and feel. It's very dark. It's very black. It's very coder-like. We can change the colors. It's so people are very excited for this. It's an option, right? People want options in how they do development. So this gives them more flexibility on what they can do.
Is there a potential way to collaborate? Like a team could be working together on stuff in there?
It's possible. The tool doesn't support it today, but definitely the framework here is very flexible to allow that. We can add extensions, things like GitHub integration. So if you have a collaborative source control management, we can do that. I joke with people, you can get ChatGPT in here as well, probably at some point.
And you can just tell ChatGPT to make it work.
Yeah, exactly.
Fix my bugs.
So, but again, these are all plugins that are all, and it's fully adaptable. So a lot of, I think we're really excited at Renesas that we're able to produce this tool for people. And I think in 2023, right, we're going to have a lot of fast updates coming that are going to make this tool really awesome.
So, thank you very much, Brett. I think really great what we are doing here. It is the next step of evolution, the next step in our development with our customers. I hope you will be here in 1 year again. We will see much more PMODs. We will see much more kits, Airball kits, boards, starter kits from our side, and you will see also some of our partners having here modules. So please come again next year. Stay interested, being interested in our solutions, and come again to Renesas and visit us on our websites www.renesas.com, and you will figure out QuickConnect Studio. So thank you very much for being here.
Thank you.
Cool. Awesome. Hi.
Hi.
Please introduce yourself.
Yeah, welcome to the Renesas Electronic booth at the Embedded World Show 2023 in Nuremberg, Germany. My name is Ben Westhoff. I'm taking care for the RAMCU product marketing, and I have the pleasure to introduce you to the latest developments if it comes to AI and MCU, embedded MCUs, right? So what we have
it's brand new.
Of course, it's brand new. It's the latest you can get, the latest and greatest you can get right now. It's basically bringing you the Cortex M85 core, which had been introduced by ARM somehow March-April timeframe last year, and we have been showing first implementation on the actual silicon of that Cortex M85 core by June Embedded World last year, whereby now, today, we're introducing the latest implementation having AI people detection implemented on these parts, right?
Is it the first time that AI is on an ARM Cortex-M?
So, no,
in
it's
that
not.
way?
So let's refine that. It's the first time that anybody on Earth had ever launched a device with Cortex M85 implementation on silicon level. And secondly, it's the first one being on Earth again, and it's not on universe side, but on Earth, have implemented AI on this course. There's no other vendor yet out there offering you Cortex M85 implemented on an actual silicon, right? So this is the running demo, and I want to, just for the viewers out there, just to imagine and experience this instant, let's say, I mean, we are very close to that now, but the instant AI experience. So let me press the reset button. There we go.
Wow.
That is MCU.
That's half a second.
Yeah, I'm not sure.
It's very quick.
quick at least, and that allowing you to have applications or to address AI to vision AI, people detection AI to application where you've not been thinking about yet before, because usually AI were implemented on MPUs where you have a kind of, or you have the audio loss? Okay, good. So where you had an MPU used, which had a kind of boot up time of 10 seconds to get the Linux running or so. This is an MCU, an RTOS, and the instant AI experience is the enabler for applications like air conditioning, right? If you have an air conditioning control unit or a wall outlet in the at home, and you're entering the room, as soon as you enter the room, this guy is able to detect you, where you are, how many people are, and where you're located, so the ventilation can be put into the right direction to get you feel cool and refreshed, right? Another application may be video doorbells, where you may not be able to detect people approaching your house. You see people coming along, and you can detect that there is a person. Secondly, you detect the person faces, and with the faces recognized, you may ring different doorbell signals, right, etc. So there's kind of a lot of different applications out there which can be used for these Cortex M85 with AI. And important to recognize here as well, compared to these Cortex M7 cores out, this is giving you a general performance uplift, a significant performance uplift of roughly 4 times compared to a Cortex M7 at the same frequency, right? That is 4 times. That is an important point you need to take away as well. So therefore, this M85 implementation is now giving you a chance to make AI, vision AI, people detection implemented on an MCU quite efficiently and enabling you to address applications you've never been thought about before.
Is it the most powerful ARM Cortex-M ever?
Yes.
The most powerful ARM microcontroller?
Up to now, let's say up to now, right?
Up to now.
Right.
So next gen, maybe it's also going on smaller nanometers than some of the previous microcontrollers? Or you don't necessarily talk about the manufacturing side?
I mean, we can talk about the manufacturing side, and we are using, of course, latest technologies for implementing our MCUs. This guy going to be part of the RA family, and RA family is known as using the latest process technologies, as 40 nanometer, for example, or even more advanced technologies in future products. So, yeah.
So it's power efficient, even though it's very powerful?
Yeah, of course. Because that's one of the benefits of MCUs. Having power efficient solution with a good power profile, and everything is embedded. Embedded flash, embedded RAM, embedded accelerator called Helium, right? So everything is there.
What is this accelerator?
That's a Helium vector extension, part of the Cortex M85 core, which can be used for, I mean, it can be used for different purposes, but we are using it for accelerating the AI interference, right? So you can use it also for DSP applications or DSP calculation applications.
Is it very special to add more stuff on the SoC and now add the AI stuff, for example, on the SoC?
It's not an SoC, it's an MCU. I mean, from our point of view, we differentiate SoC and MCU, sorry. So it's an, yeah, that's,
but
so it's
right
an
there
MCU.
On the MCU, you have the AI stuff.
So right now with this solution, as you can see, we offer a fantastic instant-on AI experience, right? You press the reset button, you have immediately performance out there. So there's literally nothing you need to add to make it a perfect fit device for various applications. I mean, this is just a picture viewer, right? I mean, right?
It feels like a Cortex-A.
Yes, it's giving you the Cortex-A feeling, but it's the actual Cortex-M, Cortex M85 CPU MCU experience.
What's down here?
That's M85 based motor control solution with predicted maintenance, right? Again, using the Cortex M85 core with a predicted maintenance algorithm in there to identify the motor turns, and there's an unbalanced load or a dead bearing or whatever in that kind of motor. You can recognize that, and then based on that information, you can call maintenance crews come along to replace that unit in the field. Of course, I mean, to be honest, this is not the typical motor you would expecting for predictive maintenance, right? This is definitely not the motor because it's a too small motor, but that's the way it is for demonstration at the Embedded World Show booth. You don't have the space to fit a large industrial motor here, right?
So would you say this is the star of the show?
What do you mean? The M85?
Yeah.
I mean,
like
come on, this is the only one on Earth.
Embedded World 2023.
Yeah,
the winner.
Yes,
of new chip launch.
And if customers want to be a winner as well, they have always the chance to come along to our booth, check out what RA MCUs look like, and check out what RA MCU can do for them, right? So we are there to
Mass
help
production.
you. This device is going to be in market this year.
Cool. Thanks a lot.
Welcome.
Cool.
Is that on pause? Yeah.
Yeah.
you.